Hello, good morning, good afternoon, or good evening, wherever you're joining us from. This is Jim McKeith from Embarcadero Technologies, and thanks for joining us for this Python for Delphi with C++ Builder webinar. Joining us today, we have the amazing David I, who will be presenting. And hello David. And Kyriakos, aka PyScripter, is going to be joining us as well, he said. So hopefully he'll be on a little bit as well to help out with Q&A. And David Millington, C++ product manager, is on here to help with Q&A as well. So great group of people to answer all your C++ for Python or Python for C++ developer questions. And with that, I will turn it over to the amazing David I to present for us. Thank you, David.
Yeah, no, it's great to be here and to be online with you, Jim, and David M. as well. So we'll just get started. I've been watching the webinar two-part series that took place with Python for Delphi, using Delphi, I guess it was a month ago or so, with Kyriakos and Jim, and said, hey, I can do this with C++. Let's write a blog post, and also then Jim said, hey, let's do a webinar. And I said, this is great. It's great to be able to hang out virtually with developers and talk about C++. So let's just get started with this. This is the agenda for today. I'm going to spend a little time about Python and C++ Builder and Delphi for Python in particular. I'm going to focus on today. Do a couple of demos and then spend time to answer your questions if possible, or follow up afterwards. So when you think about Python programming, oftentimes developers will also talk about, well, you can't do everything in Python, and sometimes since it's a scripting runtime language and system, you may need to do some optimization. And what was shown in the Delphi series was when you need some real compute intensive or some access to low-level hardware, whatever it might be, that a compiled language works great. And C and C++ have been used over time with Python to build these kind of extension modules, add-on modules, to add some performance when there's, again, compute intensive types of activities as part of the whole system. The great thing about Python is there's active community, lots of reusable packages, all open source code. I think I read somewhere with about 250,000 and growing numbers of packages and samples that are available for Python. At the same time, C++ Builder has this great component architecture, lets you build wonderful graphical user interfaces, and has the power of the ISO C++ standard language. And so, you know, it's a natural combination, as well as Python and C++ are two of the top used languages by developers around the world. Now, there's multiple ways to approach using C++ and Python and using C++ Builder. The one we're going to focus on today is using the Delphi for Python components, because, you know, component-based development helps speed up your development, set some properties, and then writes a little bit of code, and then connect it to a Python scripts and infrastructure. At the same time, you can use the C++ language to create some extension modules. Now, there's also a Boost library for Python, and the Boost libraries are things that the Boost community build that sometimes end up in the language or the standard runtime library as well. So there is a boost library for Python. We're going to focus on, again, C++ builder with the Delphi for Python components, but look for a blog post along the way by me sometime that shows what you can do with libraries as well. Now, what Delphi for Python provides is access to Python APIs and the Python infrastructure and runtime to leverage all the things that are available for Python. It also allows you to interact with, to call into and get from Python access to Python objects, data that's going on that's on the Python side, or things that you're doing on the C++ builder side to send data and to call into the Python objects themselves and use them. At the same time, you can wrap C++ objects or methods and use them from your Python code. I think Kyriakos in the second part of the webinar showed how using compiled code can speed up some algorithms. I think it was a prime number generator, for example, that took I think it was 5 seconds or so, but took sub-second to do the execution. And you can create extension modules that Python can use. So we'll look at a couple of examples in a minute about how to do a few of those things. There's multiple components and a unit that is provided as part of Delphi for Python that gives you that low-level and high-level access. So we'll see some of those in action. You can also wrap classes and objects that Python can use and provide input and output from your application to Python scripts and also base. And there's a low-level component, input-output, and a GUI component that lets you use a property to connect, for example, output from Python script into a memo or into a panel or into an area of your user interface. Now, there's several steps to getting ready to use Python for Delphi. The first thing is to install Python. And there are multiple places to get Python distributions. Most people go to python.org, and there are distributions for lots of different platforms there. There's also a system called Anaconda that you can check out. Now, depending on which Python script you might be using or wanting to use, you'll also need to install additional Python modules. And so there's a pip, which is a Python package installer. It's a command line utility, and you just pip install the name of different Python modules that might be used in some of the Python scripts. There's a GitHub repository. Take a quick look at that. And it's just search for Python for Delphi, and it'll probably be the #1 hit. Or you can go PyScripter/Python for Delphi on github.com. And in here, in this repository, there are the packages that are provided for C++ Builder, Rad Studio, Delphi 10.3 and earlier. And then there's updated packages for 10.4 and going into the future. And then there's the source code for all of the components, some tests, some tutorials, and the README down here has installation notes, supported platforms, and so on, and some tutorials and demos. So the links are all there. Just go to PyScripter/Python for Delphi on GitHub. Now, a while back, I mentioned that I also did a blog post that's on my davidiontools.com site. That link is in the slides, and we'll see that link again at the end. And that was just my first back October 13th, where I show you how to install Python, where it gets installed by default, how to download and prepare the package files, and so on. And we'll take a look at a couple of those things in a moment. So the first thing is to choose which version you're on, and I've tested Delphi for Python with the C++ Builder Community Edition, which is based on, I think it's 10.3.3, and that's that free downloadable community edition. And I use the 10.3 minus folder set of components and built those for C++ Builder, those packages and those design time packages as well. And I also am using 10.4.1, and so I use the 10.4 plus folder to build the components. One of the key items for C++ Builder developers is that before you build the components from the source code on your system, you need to set the project options, building, Delphi compiler output, C++, C++ output file generation, and choose the option to generate all C++ builder files. And that will build all the BPI files that are required, the package libs, and so on. So one way is, let's just go and pick one sample here real quick. Again, under project options, if I was loading the packages, we'd see up on the Delphi compiler, this output C++. Again, over here, small, that there's a choice here to generate ECUs only. That would be the default for a Delphi developer. But for C++ Builder, we need all the files. And depending on the target platform compiler you're using, you'll get the .a files and so on. Let's close that again. So, and it works with I only tested it with the Clang-based compilers. I should mention that. I suspect that it'll also work just fine for you on the classic compiler, but I've moved forward. I only use the Clang compilers to give me C++ 17 support on Win32 and Win64. So I also provide in a zip file from that link from that blog post batch files. And so the batch files, let's see where here's a batch file, because in the community edition, you don't have the Delphi personality in the IDE. So you still need a way to compile the component packages for Win32, Win64. And for that, I use the DCC32 command line compiler and provide different options like where the source code is, where to put the BPL file, BPI and so on. And then I copy those over to the, Studio, DCP, Python.lib, and so on. All those get compiled. If you have Rad Studio, then you can load a Delphi package and look at it and navigate through it and build it and install it into the IDE. All right. So a few steps to do. If you're not sure where you installed Python, or if you have Python installed, just type where space python.exe. And it turns out I have 3 versions of Python installed. One that was installed for something I did with Microsoft a while ago, but I have the 32-bit Python and the 64-bit Python exe and DLLs installed in my user area app data local programs Python, and then the 2 folders, Python 39-32 and Python 39. I'm using Python 3.9. I think some people are still maybe using 3.8. They also have used Delphi for Python components in earlier versions of Python. I think maybe it was 2.7, something like that. But again, I've moved forward with Python to the most recent stable release, 3.9. I think it's 3.9.0 or 3.9.3. Okay. So that's enough of the beginning information. And what I want to do now is show you a little bit about Python for Delphi and using it in an example. So we'll just say new BCL application. And here we are. And down here, I've installed the Python components, and there's the different components. The Python engine, that's that hook into the Python runtime for those versions, or a specific version you've installed, being able to create a module, get Python types, and so on. And then I also, in Gedit, there's a SynEdit set of components that allow you to do syntax highlighting of source code for a lot of different languages in the IDE. And that's a free download under Tools, Gedit. I've also, for one of the demos, there's an SVG demo that I'll show Delphi version of. I use the Athea SVG icon and SVG components. So I installed those. Both of those are available in Gedit for download. Python for Delphi, the components get from the GitHub repository. All right, so what we're going to do is we're going to look at some things. So let's go and put a SynEdit. And the SynEdit just is just like a T-memo, but it will provide syntax highlighting for different languages if you choose to do that. You could have just put a memo, and that's going to be a place where I'm going to put my Python script code. So we'll go here and align this to the top part of the user interface. And down here, as usual, here's your lines. So like in a memo, and we'll just get rid of that. Okay. The next thing we're going to do is put a panel, and we'll take a panel component, and we're going to put that down. I'm always spending my time, I don't know if everybody does this, clearing out the unneeded parts. That goes back from the first Delphi version where there wasn't a object inspector and structure window. Well, there was an object inspector, there was no structure window to find out where things are. That's why I created, just for fun, some David I components, an empty memo, an empty panel, an empty edit, and a component that gets you the build info. Anyway, okay, so we've got our panel, and up here on the panel we're going to put a button, and that's just going to be where we're going to run Python script. Okay, and then we'll go back to the form, and we'll add a T memo. That's where the output of the whatever the Python script is going to execute. Okay, all right, and that'll take up the rest of the client area. All right, let's make this button a little bigger. Okay, and then we're going to go back to the component palette, and we're going to, down in the SynEdit, there's a Python syntax component. So we'll put that just somewhere there, and then we'll add a Python highlighter to do syntax highlighting of it. And also we'll add, there's another component called Syn Python behavior, and when you're working with Python code, it will do the indentation for you as best it can. So for the SynEdit, we're going to go down to the highlighter property, and we'll use the Syn Python Syn component to say that's what we're going to use to do highlighting for whatever we put up in the area. And then for the behavior, we also want to connect that to the editor, which is the SynEdit. So behavior is going to tell this editor how to work with the language. Okay, so that's just a little bit of setup. Now we can go back to the Python components and talk a little about them. The first one we'll put is the Python engine component. And the Python engine component has several properties. Where's the DLL name that it's going to look for? You can specify a specific path, but it will also, when it starts up your application, the Python engine will find where the Python is. There's a property called use last known version. So if you have multiple versions of maybe a 2 dot something sitting on your machine and a 3 dot something, again, it will look for places and find the last known version of Python. But again, you can specify the name and the path of the DLL. There's some other properties to take a look at some point in time. Okay. We're just going to leave the defaults for now, and we'll get to the rest of it later. All right. The second thing is we want to provide a way to take output from the Python script and send it back to the user interface here to that memo that we had. So we'll put down a GUI input-output component, and its output is going to go to that memo. Whatever the Python script sends out is going to show up in the memo. In this case, the text output that's going to appear. You also have options to have it output graphics to your user interface or visualizations or other things that might be available in whatever your Python application is doing. And then we need to take the GUI input component and go over here to the Python engine component. And there's a property called IO for the input output, and we'll connect the Python engine to the GUI input output component. Now, the last thing to do is to add an event handler. And in this case, we're going to just do something simple. So we're going to take the Python engine 1, and we're going to call exec strings. And we're going to pass whatever is inside of the syn edit 1, its lines property. Okay, so whatever we put for Python script in the syn edit area is going to pass that over to Python, and Python's going to execute it, and then output's going to come back through into our memo. Now we can specify, Win32, Win64. Add another platform. Here we go. Okay, now we've got Win64. Let's just compile this first for Win32. So let's save all this to some place. Let's just create a folder, and this will just be our Python test. All right, and then let's see if I didn't make any typos. I only wrote one line of code, so anything's possible. And so it's just going to compile. First time takes a little longer to build pre-compiled headers and such on such. So we'll just say hello world, or maybe I should have said hello Python. But okay, and you notice the string is highlighted, so that syntax highlighting is taking place. Now we'll click the Run Python script button, and notice it echoes back the hello world string in the print statement. So there's a first simple test for Win32. Let's go and turn on 64-bit and hit compile and run. And again, we can put in something. This time we'll say print hello Python. And we'll click the run button. And again, 64-bit Windows works as well. So that's that first simple C++ builder project using the Python components. And we'll go on and look at some other demos. The next two demos are from our C++ versions of Delphi for Python demos. This is the same. Here's a Python engine, the GUI input output. It's got an open and save dialog, and it's just print 2+2. So let's compile and run this example. Execute the script. It does 4. We can also load another script. This is a script that's going to go to the sys or system module we're going to print the version number out and some other information about it. It tells me, okay, yes, indeed, I'm using 3.9.0. All right, from back then, and this is the 64-bit version because that's what I built for the target platform. Let's go back and walk on the wild side and compile this one, and then load that script again. Let's execute it. And now notice it's running the 32-bit version. So just to remind us that, again, as I mentioned, the Python engine will find, based on the target platform, the right version to use, and then provide that and launch it as part of your application. So that was one of the first ones. I know there's a lot of Delphi examples, and I'll get to helping convert more of those to C++ over time. So this is an example that uses the Python module component, which is used to create a module for Python, so Python can call back into my C++ application. The module has a name, and you give it its string, whatever the name you want to call it. This one's called spam. I didn't create this example. I just created a C++ builder version of it. And so then the script here just says, import the spam module, and then print out the result from the foo method, the string. So if we look at the code behind this example, here's that exec strings on the Python engine, that whatever our Python script is. We could open some other scripts as well. And let's make this a little larger. So there's two sections here. First is the spam foo method operation, which is of type py object, Python object, and then it's going to get the Python engine and call show message to return the argument or arguments of that module, of that method, and then we're going to return that. Just end it by calling, there's no return values. Usually functions have, if they're voids, then return none. Otherwise, they might return an integer, a bool, or whatever it might be. And down here for Python module initialization, we simply call the add method of the Python module component, adding that string, the parameter here, and this is the name of that Python object, which is the implementation, and then be done with it. So we can use the Python module component to create multiple methods that are going to be done in C++ to do, optimization calculations, or to do some access that Python doesn't provide to something. All right, so let's compile and run this example. And so here it's just saying, okay, it's outputting some version information. Here it's going to import the spam module and then just output back hello world. And here, executing inside of C++ Builder on Windows is the show message box that says the args of foo were the string hello world and the value 1, okay, an integer. So that's a quick sample of how to create your own add-on modules and integrate your code. And again, there are many other examples that are part of, that come with, I think there's something like 30 examples, mostly in Delphi, but we'll get to some other ones. What I want to do is show you a couple of quick Delphi examples that I haven't, or someone else hasn't converted yet to C++, but again, with some more time, we'll get done there. But the functionality is basically the same. We've got GUI input output. There's a module here, Python module for connecting FireDAC tables and sending them over to Python. And coming back. So we've got a table that'll get set up to get to Oracle, SQL Server, SQLite, and so on. All right, so let's just run this example. And okay, so here, we can test to make sure we can connect to different databases. Here's 3 here. I guess I need to add interface. This again was a pre-built demo that comes with the Git repository. So we'll just execute this, how, create a table object and send the data over to Python, where it can then iterate through and display the data. So down here, it's sending back to our application the columns and the data from each of the rows in whatever table is chosen there. And again, the second one just shows how you can get tables and columns into a grid. So here's another example. Again, we've seen this data before. This is the die shop example, and so on. Okay, so that's just a second quick example that ships. And again, stay tuned for some of these having C++ versions as well. So here's another example. What this is going to use is going to use SV. It's going to generate a nice plot of data using Python script that uses a module called matplot, and then also there's one called Seaborn that is another module for doing data science. So let's just compile and run this one. Again, Python, there's lots of modules for visualizations and things. So what we'll do is we'll just run the first one. It takes a little bit of time to generate the data and then display it. But this again is taking SVG back from from the Python code and displaying it in an area over in the user interface for all these different parts of the data. Let's just run this. I guess it's going to look at some penguin data, some common species. I don't know if I've run this one before. But what it's doing is it's taking a chart from Python and sending it back to an SVG as an SVG and displaying it in the user interface of our application. I'm not sure the speed of this one, but it might take a little longer. Oh, here it comes. Okay, so I guess these are different species of penguins and depths and build depth and flipper length and so on. So again, these are the kinds of things that you could also just do in C++ Builder itself, but why not bring the two of them together? Here's our SVG icon image component. That's part of that SYN. If we go over to Package Manager and choose which ones I have installed. Okay. Am I still there? Hello? Yep, I'm still, okay, good. So let's get just the installed ones. So down here, I've got the SVG icon list components installed, and then I've got those SYN edit for BCL components installed as well through Get-It. Okay. All right, so again, it's easy to execute Python scripts and get the results back. You can create your own modules and your own methods, and then call those methods from Python and return the results or have them do whatever it is they're supposed to do. All right, so just to summarize, there's different ways to use C++ Builder with Python. This one is just focused on the Delphi for Python set of components and runtime units. But you get the benefits of the Python open source community and the power of the C++ language and the GUI and language power of using C++ Builder to do your application development in conjunction with maybe some Python code for some parts of what you need to do. And again, stay tuned for some blog posts about how to use C++ building to get to Python in other ways as well. In the slides, and I gave Jim the PDF, so I suspect that'll show up along with the replay link on the Embarcadero blog. There's replays 1 and 2. There's my blog post. There's the link to the GitHub. Jim also did a short video on getting started with Python for Delphi about getting set up and getting oriented. There's support on the Delphi Praxis community, the English version for people using Python for Delphi, and that link is there. Dr. Bond is a courseware creator in the UK. Delphi in Python is one of the modules that are taught for schools in the UK. So there's a link in the PyScripter GitHub to the sample code and the tutorial chapter from his whole course for using Delphi in Python. But again, as you look at Delphi, the code is pretty similar. The components are the same, the VCL is the same, and so on. So Jim is putting some of those, the PDF slides are in the handouts area. And then there's a couple links for the tutorials, sample code that are part of the Webinar 1 and Webinar 2. And I have similar links in my David I on tools to a zip file that you can download with a couple of C++ that you can check out today once you get your Python runtime set up. And again, it works with the Community Edition, latest Community Edition I've tested, 10.3.3, and also with the latest release of Sydney 10.4.1 or 4.0 for that matter as well. You still haven't updated the update. Okay, so with that, Jim, I'll turn it back to you and whoever and see if there's any questions. And,
okay.
Yeah.
There are a few questions here. One question is about what versions of C++ Builder this works with. Now you said you tested it with the 10.3 and 10.4. It should work back a few versions as well. I don't remember exactly how far back it goes, but I remember Kiriko saying that it worked with quite a few versions of Delphi. So it should definitely work with 10.2 as well.
Yeah, there's in the packages, Delphi, he goes, 10.3, and he puts 10.3 minus for the folder name, so that I didn't test anything before then. I'm always moving forward. So for C++ Builder, again, I wanted to make sure the 10.3 and also the Community Edition that some people might have as starting, and then they move up to Pro Enterprise Architect on C++ Builder. And again, I provided the batch files for building them. I think those were, if you looked inside of the batch file here, I was doing that with just 10.4, or no, this was 10.3.3, so 20.0, we're up to 21.0 for Embarcadero Studio and C Builder 10.4, but this shows an example. So you just want to, you grab those batch files as part of my zip download in my blog post. You can change these for wherever you installed Python for Delphi, and then the runtime folder name. And this was, again, Delphi 10.3 minus was when I built this batch file for the Community Edition.
Yep. There's a question here about downloading the PPT. It's available as a PDF. You can grab it from the handout section. And possibly we'll see it added on to the repository as well. I'll send it over so that it can be added to the tutorial section of GitHub. And also, David, you can send your batch file and your samples, and they can be added to the main repository too.
Okay.
That way they can be available in place.
And I'll just put a comment on them that this was for 10.3, just to let people know. But again, you can make those changes to the batch files. The other thing is that, sorry, I use LibreOffice Impress now for my slides. So when I tried to save it as a PPT, it didn't quite come across very well. And the feeling that really got lost was the Impress background theming. But Jim, I think I sent you the ODP file, I think it was. But if I did, I can send it again, and I can save it as PPT. I'll try to figure out why Impress, when it said save as PD, PPT, it didn't, probably because it didn't know what to do with the Impress theme. But the bullets still came across, so I'll make sure to get that to you as well.
Yeah, I don't have LibreOffice installed right now on my desktop. I think I have it installed on a Raspberry Pi someplace here. I could go over there.
No, I'll just send you a PPT. I'll look at it this time before, make sure it's clean as far as the bullet points and notes are versus this theme that I chose for the little things on the outsides.
So there's a couple of questions. There's a question here about performance in general. Now, I know that when I talked to Kirikos about it, he said that there is minimal to no overhead in the calls here because it is just straight across calls. It would be exactly as if you were, launching a Python script from a console window as far as launching it from C++ Builder application. The only place there may be a bit of overhead is if you are using the reflection-based commands in order for Python to call back into your C++ Builder application. But again, that's a very, very minimal amount because it happens once to it's RTTI, runtime type information, to gather that information. So very, very minimal, and that would only be at the launch, but not at runtime. So
yeah,
very minimal.
The Python code is going to run slower. I mean, it's just then natively compiled C++ code. So
right. Yes. Yep. Yeah. So yeah, if anything you can run in C++ code, native code, C++ code will be faster than the Python code. But as far as the bridge between the two, you're not really any kind of performance hit there.
Yep.
Actually, I was talking to, since the last webinar, I talked to some users that are using Python for Delphi in production, and what they've been doing is they use the Python libraries to provide a greater breadth of digestion algorithms, but then the ones that they use are important, they re-implement in Delphi to get that performance benefit. So that way they can let people use whatever digestion libraries they want to import the data, but then the re-implement the really key ones that they use a lot in Delphi in order to get the performance benefit of native compiled code. And so the considerations for app deployment, there are two different ways you can tackle this. One is you can require the end users to have Python installed. The second way is there is a embeddable version of Python. I guess it's not really embeddable, but a special light deployment of Python that you can use that just is, I think, a Python DLL that you can deploy with your application. You just have to make sure you have the 64-bit versus 32-bit version, depending on what your application is. So that's really all this is. There's one additional DLL that you need to deploy with your application.
Yeah, I'll make a note. That'd be a good little short blog about how to, and I can test it on a VM that I have here to test how to package everything up so that you don't need like demo one, simple demo, for example, or the second one or any one. That'll be good. That'll be a good note to make.
Yeah. When you were doing the SVG, sending the chart data back and forth, is there a limit to how much data you can send back and forth, or what is the channel that the data is sent back and forth between the two?
Basically, it's a text representation. SVG is a text file, so you just pass it to a string variable, and you pass the string variable to the SVG component in Delphi. So basically, no streaming, no files, just passing a string variable from Python to Delphi and into the SVG component. That's how it works.
Can you answer the version of what versions of Delphi this would work with, or C++ Builder?
It should work for all the Unicode versions of Delphi. It also works with FPC, so it's a broad compatibility. Now with C++ Builder, I haven't tested it, so I'm not using that. So, but I suspect it's the same versions, the equivalent versions for C++ Builder. That's my suggestion. As long as it compiles in Delphi, it should work with the corresponding C++ Builder.
Okay, that's what I figured. All right, great, thank you. What sort of libraries are there available? I mean, you mentioned there were thousands of libraries for Python. What sort of libraries are there for Python that a C++ developer may specifically want to take a look at? Oh, look, there is a list of all the, quite a few versions are explicitly supported in there. So there's a lot of machine learning, big data libraries are pretty popular in Python. That's one of the main use cases. We see Python being used a lot. So if you want to be able to leverage those things from C++ Builder, that's something you can definitely look at. Any other, there's some graphing ones, trying to think of some of the others. There's quite a few out there. It's pretty diverse collection of libraries. So you're embedding the Python in your application and expose that to yours to let them modify or create Python scripts that can then modify your application. So you could do things, for example, the Python script could move components around your form, could interact with objects within your application, could change the values of things or whatever. Basically, you can expose as little or as much of your application to the Python engine as you want, and then the Python script can then modify that however you want to let your users do that. So there's a question here. Someone just came in asking when we started. So we're actually just wrapping up here. Sounds like there was a time zone issue. I've been working with time zones all the time for I don't know how long, and always something goes wrong with time zones. They are a mess. There's a question here about memory cleanup, David. So if from the C++ Builder side, do you need to be concerned about the memory allocation and deallocation from the Python scripts objects?
Only in your own C++ code. If you're doing something special in C++ code and you allocate some memory, you need to free that back up. But maybe Kyriakos knows. There's nothing I've seen. I've tested memory leaks, and I didn't see anything on the Python side unless there was some Python module that was leveraged that is misbehaving.
No, there's not such an issue actually. I don't know specifically for C++ Builder, but otherwise, when you use Python, you got to be very careful with reference counting. That's the only thing. But if you use the high-level wrappers like varpyth and so on, then that's been taken care of. Otherwise, if you work with raw Python interface, it's a minefield. It's a minefield because you got to be very careful releasing the references of the objects or adding references to the objects and so on. But the varpyth, for example, which is the high-level interface to Python, that's all been taken care of. So it's been widely tested, and there are no memory leaks.
Okay, great. Yeah, it sounds like you can have memory leaks if you try hard, but it should behave in an expected way for sure. So Miguel has a question here, and I'm not sure that it's one I can answer because I'm not really familiar with Python or Py++. That says beyond the GUI functionalities that C++ Builder provides, how does C++ Builder for Python or Python for Delphi stand versus other solutions? I'm not really familiar with the other ones, but it's as far as, I mean, it gives you as low level of an interface as you want. So it gives you the ability to create Python libraries with C++ Builder, or to consume C++ or consume Python from C++ Builder, or however you want, whatever you want to do with it. Anything either of you want to add on that? If you guys familiar with Python or Py++?
No, I looked at those a long time ago, but again, for me, what I'm doing is I'm using native code, whether I'm using C++ Builder or Delphi, for all of the work that's being done. What's happening on the Python side, that's the Python runtime that's continuing to evolve over time. So I can't speak for that part. But again, what I do in my own code, the components are all compiled native code components. The modules that I create are compiled, optimized C++ code, whether it's the GUI or the modules and functions that I create. So I haven't tested C++ Builder or Delphi with other kinds of Python runtime. So it's a good question. You know, my email address is on there. So if you send me an email, sorry, it's my full name at gmail.com. You know, I can take a look and try and do it. I'm always looking for blog posts, do some kind of timing comparison, but you know, native code to native code, separate from the Python script code, of course. I don't know that it makes sense to compare doing something in Python script that might be, you know, pre-compiled versus doing something in C++ or Delphi code, how that might compare. Maybe that's what is implied in the question. I'm not sure.
So the var Python bridge gives you the ability to expose records and types and variables between Python and C++ Builder. So any kind of basically from your C++ Builder application, you have complete control of how much or how little of your application and your data that you want to expose to Python. So if you wanted to use Python as like a plugin engine for your C++ Builder application, you could totally do that, and you could control exactly what that interface looked like. So there's a question here on mobile, and I know here at Host we have someone's working with you on adding Android support.
Yes, indeed. Actually, the first target is to get FMX wrapped. That is the first target we're working on. Mobile comes next, but it does appear to be slightly more complicated, the Android stuff. Android we're targeting, not the Mac iOS, not the Apple phone. But yes, I mean, there is work taking place in that direction. So I will actually announce that when it becomes available.
Fantastic. Yeah. So that we're at right now, there's a module that will wrap all of the VCL and RTL into a Python module so that it can be consumed for Python. So we're adding one that will do the same thing for FMX, and then it will allow you to build a expose FMX and all the RTL as Python modules for Linux, Windows, and Mac OS. And then after that, then there'll be a Android module, or Android support is what we're looking at. So yeah, very exciting to see.
Yeah.
In theory, it should work, but it hasn't been done yet. So Christos is saying, I'm trying the last 3 days to install Python for Delphi package in Delphi Community Edition, but shows the same error, Python GUI input output not found. So it sounds like you need to add the path to the source file, or the package isn't installed, depending on what the error message is. If the error message is related to the package or to the component, then you don't have the package installed. If the error message is related to the unit file, here David's bringing up right here the
here I'll go C++, sorry, paths and directories. So what I have here is make sure that you have the include path set, and over here the library path set. These are here. I just set, you know, to get to it, the dollar platform. That's for, you know, config and so on. But go ahead, Gracos.
Yeah, so I think I did a video for Delphi at least that walks through the getting started as far as like how to install it.
Just to say, I'm afraid I'll have to go now. I have another meeting. But there was a reorganization of the packages recently, so just make sure you update the repository to the very latest version first, and then try to install the packages.
Yeah. Okay. Good point. So yeah, update to the latest version and give it a shot.
And if there is a problem, just submit an issue and we can take care of this. Yeah, submit an issue to the GitHub repository.
Okay. All right. Fantastic. Thank you so much for being here and for all the work you do on this on the project. And we'll talk to you later, Kyrgios.
Thanks very much.
Yeah.
Thank you very much indeed.
Here in Python for Delphi, I had to make a small change too because the VCL, because FMX was added for Windows, there's a namespace for the VCL to get to certain components. Let's see if I can get to that. And then there's all these known versions and so on. But there was an example. But here, if you just grab the latest repository and on the wiki, there's a link to the install, and you just need to wherever you installed it. In this case, put it in D components. You need to have the source, VCL, and FMX for the source subdirectories and the library paths for those for each of the targets, or you just put the $ target platform and build type. Because I had that when I moved from a previous version as well. Let's go back to this one here. You'll notice in the uses that it's got a VCL in certain cases in front of it. But yeah, check out and make sure that you have the directory path set for the library path so you can find it, and the source path as well.
Yeah. So Christos, go look and make sure you download everything and look on the repository to see if there's any files that you didn't get downloaded, and then follow the installation instructions. I will test it again here to make sure it works with the package reorganization, but it should work. So yeah. Miguel saying, since there are a lot of ways to integrate C++ with Python, it would be a great idea to try and run some benchmarking versus Python for Delphi with C++ Builder. It's very well known in the C++ community that the integration with Python in bridge mode is quite difficult. So there's no overhead performance-wise, but David, did you find it difficult to do any of the C++ integrations?
No, it was really just in looking at some of the samples, twisting my mind on some of the Delphi isms to put them into C++ Builder isms. Things like enums, for example, just making sure that those are handled properly. And again, the best way that I find is I can go to the doc wiki, and there's a section on if you see a set being used, there's no sets in C++, here's what you need to do. That gets an array of, if it's strings or whatever. Those are the only things. There was nothing I had to do at the component level, in building the packages. There was nothing special I had to do there. It was more the usual, okay, remind myself, how do I do that again in C++ versus Delphi for just a few things. But like enums, parameter types, namespaces, making sure the namespaces are set, or that you fully qualify the namespaces with the colon. That's the only thing that I just have to think about when I'm looking at a Delphi example and wanting to create a C++ Builder equivalent of it. But I haven't run anything in the components building themselves other than making sure that I had those paths set correctly and that I build, Win32 and Win64 versions to use in VCL applications or command line applications. Again, I'm going to explore probably in January using the Boost libraries with Python, and maybe a few other Python to C++ examples that aren't using Boost, which is supported by C++ Builder, and see what I can write up for people that want to use a more direct approach. But if you have suggestions for what you want me to explore, just send me an email. I'm happy to do as much C++ as possible because of some things that I'm working on for 2021 with C++.
So the question here, one thing left with the impression that as such a young language, Python has more libraries than C++. Is that right? And how can this be explained? I don't know. So C++ has a lot of libraries. I would expect it probably has as many or more than Python. Do you know, David, on either way on that?
I don't know that there's a count. I mean, C++ has been used for a lot longer than Python. I think, in my mind, we have to maybe look at what you can do versus how many, because there are visualization libraries. There's, real-time libraries for C++. There's all sorts of things for C++ over the years. Cross-platform and on and on and on. In fact, some of the systems that people use elsewhere, the runtimes like Python and such, they're built in C and C++. Right? So even they rely on the C and C++ language for their use, their implementation. But it's true that in recent time, as Python has been used for example, data science, machine learning, and so on, there are more libraries that are being talked about in some of these new technologies. But at the same time, Al Manarino did a talk webinar about going from Delphi and C++ Builder to IBM Watson by using a REST interface. So there's lots of different ways to get to systems that people think are interesting and exploring in those worlds of visualization, machine learning, deep learning, AI, and so on. But as I look at those interest areas of where the jobs are, what people are using, what they're learning, and so on, C++ is right in there. I don't know of many people that are using Python for real-time systems, time-critical systems, maybe a combination of things. I think it's more the sort of modern data science world that we're seeing. What is it, PyTorch and so on, these different AI-based libraries that people can use. But you can get at those from C++ or Delphi as well.
Yeah, I went and looked. The Python's actually 29 years old. I knew it was pretty old. I didn't know it was that old. So it was released actually before Delphi. But the behind the scenes though, most Python libraries, not all, but many of the Python libraries are written in C++ or C. So because the Python itself is a higher level language and isn't as performant as native compiled languages. So whenever you need performance, you have to have that library implemented in a native performant, a native compiled tool. So I don't know that there's a meaningful metric there to say which one has more libraries or what you could do is more with one with the other. Generally, I think you're going to have more breadth of things you can do with C++ because Python is limited by its libraries, whereas C++ can write the libraries that C++ or Python uses. Beautiful Soup plus Delphi would be nice. Python, Excel, Delphi. I'm not sure if I'm familiar with Beautiful Soup.
Me neither.
Yeah, but really the thing is that if you're there's a lot of potential here for bridging these things. Where is it that you want to find, if you're like, I don't see any use for Python in my C++ development, then that's fine. But if you're like, oh my goodness, I want to have access to this library, I want to have access to this ability, or I want to expand Python with a library, then that's really where this comes in for you. All right. Well, thank you so much, David, for putting this webinar together.
It was my pleasure, and everyone who's out there, stay safe in this crazy world. Have a great holiday period coming up, and a happy new year. And we'll look forward to even more good programming in 2021.
So apparently Beautiful Soup is an HTML parser analyzer for web scraping, so it can parse web pages. So
okay.
Yeah. So one thing that's great, and so one use case that's really good for this is, let's say you're like, oh my goodness, Beautiful Soup looks so useful, I want to have that. So you can totally just consume Beautiful Soup directly from C++ Builder. You can access those Python libraries as if they were C++ libraries, and just use those. So it's great. GitHub has more than 208,000 libraries written in C++. Wow.
That's just GitHub.
Yeah, that's just GitHub. And C++ has been around for quite a while. Okay, well, fantastic. Thank you so much, everybody, for joining us. Thank you, David, for your efforts and all you do in the community in general. And we'll all definitely stay tuned to your blog for more.
Yeah, I blog both places, David I on tools, but when it's more general, when it's more specific to Embarcadero, then I have the blog on the new Embarcadero's blog as well, and I'll try to make sure that anything that's C++ Builder related gets put and or linked to blogs.embarcadero.com. So you can look both places.
All right, fantastic. Thank you, and thank you everybody for joining us.
All right, bye everyone, take care.
Bye everyone, take care.
So this is just a quick look at creating a database application with C++ Builder. I'm going to go use C++ and do multi-device. This should work mostly the same with VCL, but the difference is because I did multi-device, I have more platforms over here. So VCL, you just have Win64 and Win32. Also over here, we have the Data Explorer tab. This supports both FireDAC and DB-Express. FireDAC is the way to go, although if you want to use DB-Express, it's there too. And we're going to use Interbase. Right now, we ship with the employee database, just a sample database. So if you've installed FireDAC and have it set up, then you will have the employee database. And I can connect to that and see the tables. And we're just going to use the customer table here. If you want to add others, you can add a new connection. It's going to ask you for a name, and then it'll bring up a dialog like this one where you can specify the driver and the database, username, password, stuff like that. So I have the components down here in the form. This is the connection to the database. This is the connection to the table. I can go to the query editor. By default, it just selects star from customers, and I can execute this and see down here. Actually, put this down in the corner. There we go. See all the data. and see the structure of the database, the data in the table, and say, yep, that's what I want. You can optionally, this isn't required, come in here to go to Fields Editor and add fields. And this will create variables for each individual field, but this isn't necessary. And now to display the data, I'm going to use a grid. I'm just going to use a regular grid, T-grid. Let's not drag, I want to drag the whole thing. Or not drag it, I want to resize it. And then we'll go to bind visually. And there actually is an option where you can run the wizard here, the bindings wizard, and create a grid automatically. But I don't know. I don't do that. I probably should learn to do that. I like doing stuff manually, believe it or not. Okay, so I just connect the grid, the star on the grid, to the customer table. But when I did that, it actually created this binding source DB and binding list. And you'll notice it changed this to say bind source DB down here at the bottom. Now and you'll see that the grid now has columns in it. Now I can go to this and say active true and see the data at design time. I can even hide those components if I want to. Before I do that, I'm gonna go to the bind source DB and say add navigator. And this puts a navigator bar that just makes it easy for this quick and dirty CRUD application to navigate through the data. And I do need to write one line of code. In production, you're going to write a lot more than one line of code, but you know, this is just quick and simple. Customer table open. Oops, put the star in there. Oh, I was also going to show you, you can come in here to the columns editor and add columns. Again, this is optional, but this gives you the ability to come in here and change the header from cust number to cust number sign, because we're fancy. Oh, let me hide the, there we go. So now it says cust number. Okay. And at that point, my project's all ready to go. So I'll just run it. Give it a second here to compile. And there is my application. And I can come in here. And if you watch the bar here, when I click in here to edit the cell, as soon as I start editing it, so we'll change it to big, we'll see that we now have the commit button here. And I can click that and commit it. Or if I say, as soon as I go to the next row, it commits it automatically. You can also use this for add, refresh, navigating to the top and bottom, stuff like that. Anyway, there you go. Quick and easy, simple, creating a CRUD application with C++ Builder, connecting to Interbase using FireDAC.
So hello everyone and welcome back to the Migration and Upgrade Centre. My name's Stephen Ball and I'm joined here again by our senior experts Al Manarino.
Hello.
And also Mary Kelly.
Hello.
So last time out we looked at the top 5 things to consider when converting applications, and in this video we're going to take our theory and put it into practice as we upgrade from an old pre-Unicode application that uses the BDE up to the latest RAD Studio 10.4. So like many people converting their applications, the key driver here is to show how to get the application supporting 64-bit Windows, and also to we're going to cover warts and all what we have to do to make that move. So the application we've chosen to have a look at is the Mast App Demo from C++ Builder 6, and it provides a number of migration challenges, elements to look at along the way, but it's also one that's relatively easy to look at, so we'll take that as we go through. So Al, Mary, we've got the app here running on the C++ Builder 6 version. So what's the first things you notice here?
Well, we're going to need to check out the icons on Windows 10. I have a feeling that as we move up, the change in the resolution support in Windows 10 is due to high DPI is going to cause the icons to look really small on most machines.
Yeah, no, agreed. I also think we might need to check out what's behind that help button. Our Macs have changed the help systems a number of years ago, so that could be an external dependency that we need to modify. So I tell you what, do you want to just pull up the code there and let's have a quick search behind the help button. Yeah, I can see the first item there. It's a HLP file, so we'll need to get that updated to a CHM.
So I'm also curious to see what's behind some of these other buttons. So let's try the browse button.
All right.
Looking at this orders by customer screen, if we look at the scroll bars there, we might be able to use a little more screen space. So this is another area we can look at for UI modernization.
Yeah, and I think we'll also gain some usability wins here with updating this calendar to the VCL calendar view in 10.4.
Yeah, no, agreed. It might be worth a quick look at the cust query form in the project there.
All right, let's find the date form.
So, there seems to be, we've got a property for the date time there, and we've got the read and the write. Can we have a look at the source there? But at least it's using the date off the control, which is kind of cool. But I think having those getters and setters, it could be quite easy then to actually switch that out with the modern Windows 10 controls. That should be a really, really quick thing to do.
Yeah.
Okay, so should we have a look behind the data? Yeah, go on now.
Yeah, see in your list there's a data module, so I'm curious to see what's inside the data module.
Yeah, let's go ahead and open that up.
I assume there's a form that goes with it, but just looking at the code here, I'm seeing T database, T query, T table. So this to me is the good old BDE, the Borland database engine. So this is definitely going to be an issue on Windows 10 64-bit, because as many of you know, about 20 years ago, we deprecated the BDE. So it was never tested or certified on these newer operating systems like Windows 10 64-bit. It's never going to support Unicode. It's never going to support 64-bit. So if one of our criteria is to move this app to Windows 10 64-bit, the BDE will not work for us. So we'll need to migrate off of the BDE to a newer, more performant data access component like our FireDAC component.
Yeah, I think we've got the BC demos database there, pointer paradox. So yeah, that's definitely going to fail our 64-bit requirements.
Yeah, I've been using the Interbase Database pump recently to update some of our customers from Paradox to Interbase. So this would be a really sensible path, especially with the runtime free IB Lite version.
Wonderful. So I'm agreeing so far with everything we discussed about how to migrate this legacy CBuilder 6 project over to the current CBuilder 10.4 and get it to run on Windows 10 64-bit.
Okay, cool. All right, team. So I think we've had a quick look around. We seem to be getting a plan together. I think first things, let's get the code to open in 10.4 without reporting any component errors. Then sort out any Unicode analysis that we need to do. And the database side of things might make sense to go straight to FireDAC because we know we're going to have the challenges with 64-bit for the BDE. Al, is that something you can do?
Yes, I'll take care of showing how easy it would be to migrate off of the BDE and over to a newer, more performant data access control like FireDAC. So I'll take care of that one.
Cool, thanks, Al. And then we need to point this to Paradox IDBC for the initial test. But then, let's look to maybe get this into Interbase so we can take 64-bit support into the equation and also enable multi-user access onto the database.
I can pick that up.
Okay, great. Thanks, Mary. Then I'll sort out the help file, which just leaves the kind of UI modernization elements to do.
I know of a good site for us to get some icons for multiple resolutions that we can swap in with the modern T-Speed button, which supports image lists, and I can also sort out the calendar controls.
Okay, great. So guys, I think we have a plan. Let's check this CBuilder 6 code in, and then I think it's over to you, Al, to get the initial bit done.
Excellent. Stephen, Mary, and myself will be working on this C++ Builder code migration from different locations, so it's a great idea to upload the project code to a version control system. C++ Builder has built-in integration with 3 of the most popular version control systems, Git, Mercurial, and Subversion. For our project, we will choose to use Git. So here we see our C++ Builder 6 Mast App project uploaded to GitHub at this Git URL. So now using GitHub, we will be able to collaborate and look back at previous versions of our work, and Git will keep track of all of our changes to the code. Now, to get the GitHub project onto our local disk, using the C++ Builder 10.4 Sydney IDE, we can use File, Open from Version Control, and select Git. Click OK. And now for the Git source location, we will select our GitHub URL, and for the destination, we will create and select an empty folder. I'll go to my documents. I have an empty folder called C++ Builder 6 Mast App that I'll use as my empty folder as my destination, and click Select Folder. Click OK, and our GitHub project gets cloned to our local drive. So here we get to select the project file for our C++ Builder 6 Mast App application, which is the mastapp.bpr file. Click OK. And our GitHub project gets successfully cloned to our local drive. Looking at the source code from the GitHub repository, now on our local file system, we see that the project file for the old C++ Builder 6 project is a .bpr file. The BPR file was the extension for C++ Builder 1 up to at least C++ Builder 6. Now, since the separate IDEs for C++ Builder and Delphi were merged about 10 years ago, the default project extension for C++ Builder is now a .cbproj file. So the first tip I have for you is do not let the current C++ Builder 10.4 Sydney try to convert your old .bpr project file to the new .cb project format. In fact, if you try to open up the old .bpr file in C++ Builder 10.4, all you get is the file opening in the editor like this and showing you the contents of the .bpr file in XML format. Too many aspects of the project file, from the .bpr to the current .cbproj file, have changed between the year 2000 and now. So my advice for the CBuilder 6 to CBuilder 10.4 project migration is to first copy all of the old CBuilder 6 project files into a new folder, like we have done so already. Next, in your C++ Builder 10.4 IDE, create a new C++ Builder project of the same project type. So in our case, it'll be a new Windows VCL application C++. Next, we will save the new project to our new folder, File, Save Project As. We will save our project to our CBuilder 6 Mast App folder. For the file name, for now I'm going to just rename it to Remove Me to remind myself this is the auto-generated unit1.cpp from the new C++ Builder 10.4 project. Since it's not needed for our application, later on we will select and remove this file from the project. For the precompiled header, I will call this my Mast App precompiled header. And for the project file, it'll be our new Mast App project for C++ Builder 10.4. Next, we want to use project add to project, and we want to add all of our C++ Builder 6 project files. So that's all the .cpp, .h, .hpp, and .dfm files, plus any resources from our old C++ Builder 6 application into our new C++ Builder 10.4 project. And the first error we get trying to open these files in C++ Builder 10.4 is error reading from customer by invoice report, class T quick rep not found. So let's just click cancel for now. And this is followed by error creating form, class T quick rep not found. Click OK. The next error we get is unknown database, alias MAST. For now, let's just click OK. The third error we get trying to open the CBuilder 6 files in CBuilder 10.4 is this unknown database, alias BC demos error. For now, let's just click OK. And we get another unknown database, alias MAST error. So for now, let's just click OK, and we'll come back to these errors and explain what they are and what we need to do to resolve them so we can move forward with our project migration. And the last warning we get is ignoring the old CBuilder 6 mastapp.bpr file, because we cannot add another project to a project. So that's fine, because for our C++ Builder 10.4 project, we will be using its new .cbproj file instead of the old CBuilder 6.bpr file. So here we can just say OK. So now we see the CBuilder 6 Mast App project files in our C++ Builder 10.4 Sydney IDE. Recall in our introduction, we mentioned that this CBuilder 6 Mast App application uses the BDE to access local paradox tables. So let's now look at the data module, the datamod.cpp file for the BDE components. So here we get an error saying error reading from mass data, class T table not found. So this error tells me that the BDE is not installed in our C++ Builder 10.4 IDE. So as part of this migration, we will need to install the BDE into our C++ Builder 10.4 IDE. And later in this migration, I will show you how you can install the BDE into your C++ Builder 10.4 IDE for backwards compatibility. So at this point, we can just click cancel. So now, since this project is under Git control, any changes we make to this code will be logged by Git. And lastly, from the IDE project manager, I will remove the auto-generated unit1.cpp that I renamed to removeme.cpp from this new C++ Builder 10.4 project, since it's not needed for our application. So select the file, right-click, remove from project, remove this item from the project, the removeme.cpp, click yes. So now that auto-generated unit1.cpp has been removed from our C++ Builder 10.4 project. So all of this is great. Going back to the cbuilder6.bpr file, the old .bpr file still has value for our migration. So as you can see here, you can still open up the .bpr file inside of C++ Builder and treat it as an XML file to see, for example, what headers you need to add to the application, plus other useful information like what libraries the project used, what packages are needed, plus a file list of all the files that are needed for this project. So I stick with the advice of don't let C++ Builder 10.4 convert your older CBuilder project file. Instead, do what we did here. Copy your files into a new folder, create a new project of the same project type, in this case a C++ Builder VCL project, and then add your source files to it. It's a little more effort at first, but it will save you a lot of time later on. And I stick with this advice even if your project has hundreds of forms and or hundreds of classes in it. And one more note to mention is, if you had third-party component extensions for CBuilder 6 or any other legacy CBuilder project, be aware that some of the freely available libraries from the past may no longer be available or still supported. However, the good news is the range of components that are bundled with CBuilder 10.4 is much greater. So if any old component is missing, there is a good chance you may be able to replace it with an equivalent new one from C++ Builder 10.4. So now our project is under Git control. And when we make any changes, we now have Git control to be able to commit, pull, show log, clean, and or push those changes. So all of that is great. To get the BDE for C++ Builder 10.4 Sydney, you can log into your registered products portal page at my.embarcadero.com using your Embarcadero Developer Network username and password to log in, and then click this Cloud Download button on the left panel and search and find the BDE for Rad Studio 10.4 and click the download button to download the installer for the BDE for C++ Builder 10.4. Run the BDE installer This will install the BDE runtime headers into your C++ Builder 10.4 IDE. The BDE has been installed successfully. Click Finish. Next, we also want to see and use the BDE design time components, like the missing T database component, in our C++ Builder 10.4 IDE. So we will also need to install the BDE design packages for the BDE components. We do this from our C++ Builder 10.4 IDE by selecting Component, Install Packages, clicking the Add button, and we browse to the bin folder of our 10.4 IDE installation, and we search for and select the package called DCL BDE 270 and click Open. Now when we look at the install design packages, we now see we have Embarcadero BDE DB components listed as one of our install design packages. And if we click the components button, we see we have the BDE installed components, including our missing T database component. We also see we now have T query, T table, and all the other needed BDE components for our application. So now that we have the BDE installed, let's try and reopen the Mast App project and see if we resolved our missing class T database not found error. Let me again select the customer order form that uses the BDE, and we see now that the customer order form opens up just fine without any missing BDE components. So all of this is great so far. Let me now pass this migration to Mary to explain and fix those errors we got opening this project in C++ Builder 10.4. The unknown database, alias mast, and BC demos, and the T-quick report not found error.
In Mast App, our data module is currently using one of the older paradox tables in C++ Builder. The aliases mast and BC demos are actually the DB demos paradox example that we shipped with both Delphi and C++ Builder. Soon, we'll be migrating entirely away from Paradox to Interbase, but to quickly solve these issues, we're going to go into the data module components and make the switch to DB demos to get prepped for our Unicode, FireDAC, and UI updates. So if we go ahead into the database editor, we can see here that the name it was given is called Mast. We're going to switch this to DB demos. And click OK. So now the new database and alias name are now DB demos. If we go ahead into our orders to custom order items, parts, employees, and vendors, all we have to do is go through and just change this to DB demos for each of them. So just going through all of the rest of these DB demos for all of our data source components. Now that will end up getting rid of the unknown database alias, either mast or BC demos, and we'll actually be able to connect to our backend data source. And now when we go into our DB demos data module, we no longer have the error unknown database alias mast alias BC demos that appears. We're now connecting to the DB demos database on the back end. The error that we're seeing right now is what you run into when you open a project that's missing third-party components. Now, a question we always ask is what third-party components or libraries are you using in your older C++ Builder projects? The reason we ask this is because third-party plugins need to be rebuilt in the current C++ version. Now, having the source code makes this a lot easier, and if the libraries are still maintained by a group or even available as open source, then you can still use them with minimal to no changes. Now, on the other side, if the components are not available for our current release, then you still have a few options available. You can either switch to a different component set, or you can just remove the components entirely from your project. While Quick Report is still available today as a third-party reporting component set, we are going to choose to remove it from our Mast App application. So let's go ahead and see what we need to do to get the library code removed. To get started with removing a third-party component from C++ Builder applications, such as the Mast App application. Now, before we get started with actually removing the components for our reporting component set, we need to know exactly where it is within the application that our reports are either being generated or called from within the code. Now, specifically for the Mast App application, the majority, if not all, of the reporting components all fall directly from the main form. So we'll be mostly sticking within the main files to remove the reports component from Quick Report. Now, if we take a look at reports, we can see here that the on-click event property is report button click. And we can also go ahead and see within our header file just how many procedures we actually have to remove for this application to no longer draw any dependencies to the Quick Reports components. Looking at our header file, we can see that the report button click along with file printer setup click and file print report click are also going to have to be removed. The print invoice report, the print order report, and customer report. So overall, it looks like we have 6 different procedures that we're going to have to remove, along with the T-speed button for reports. If we look at the main source code, we can see the customer, order, and invoice reports all at the bottom in our include statements. I can go ahead and remove or comment these headers out. Usually you would just remove them, but I'll only be commenting out the code instead. We can now work through commenting out the code for the procedures in our source file. Since we no longer use any printing in our application here either, we can just comment out that as well. And now that the code is inactive, we can comment out the procedures in our header file. We can go back into our design page and remove the report button, and then we can reset the rest of the buttons on the main form to their new position without the reporting components. Moving into the Mast App project file, we can scroll down to comment out and prevent the forms from being created from within the project. Our last step will be to remove the source files from the project manager. The 3 files were the customer report, invoice report, and order report. Just finished removing these, and now our application has 0 or no dependencies on our Quick Report components anymore.
Now that we have the BDE installed into our C++ Builder 10.4 IDE, let's now look again at the data module that uses the BDE for data access to local paradox tables. Our data module is this data mod form. In this data module, we see we have the BDE components like the T-database component, T-table component, T-query component, and the BDE T-data source component. As we discussed earlier, this CBuilder 6 Mast App application is an order entry system that uses the Borland database engine, the BDE, for access to paradox tables. This application uses and interacts with the orders table, customer table, vendors table, items, parts, and employees table. As many of you know already, the BDE has been deprecated for the last 20 years, so we really need to migrate off of the BDE to a newer, more performant supported data access layer that supports Windows 10 64-bit and modern security standards. Looking at the Data Explorer tab in C++ Builder 10.4, we see we have DB Express and FireDAC for data access layers. Now, since the BDE is deprecated and Embarcadero advises not to use the BDE for any new projects, since the BDE is no longer supported and the BDE was never tested or certified to run on the newer operating systems like Windows 10 64-bit and the BDE will not support 64-bit Windows applications, and the BDE will not support Unicode. So Embarcadero's advice is to move off of the BDE to a newer, more performant data access component that is certified and supported by Embarcadero. Today, our newest and most performant universal data access components are called FireDAC. So now let's take a look at a few approaches you can use to migrate both your C++ builder code and forms from the BDE to FireDAC. One good point is the architecture of the FireDAC database access library in C++ builder is very similar to the now deprecated BDE Borland database engine. And this was one of FireDAC's original design goals, to be a replacement for the BDE. And as we see here on this DocWiki page, BDE name counterparts for FireDAC, we see a table that lists the main BDE names and their counterparts in FireDAC. So for example, a BDE T session gets replaced with a FireDAC T FD manager. A BDE T database gets replaced with a FireDAC T FD connection. A BDE T query gets replaced with a T FD query. And a BDE T table gets replaced with a FireDAC T FD table, plus all the other BDE names and their counterparts for FireDAC. And at the bottom of this DocWiki page, it says you can find the full list of all the BDE name counterparts to FireDAC in a file called FireDAC Migrate BDE Text in your FireDAC Samples folder. So now going back to the data module in C++ Builder, one approach to migrate off of the BDE to FireDAC would be to do a search and replace on the BDE syntax name and replace it with the FireDAC equivalents. So for example, a BDE T database becomes a FireDAC T FD connection, and a BDE T table becomes a FireDAC T FD table, and a BDE T query becomes a FireDAC T FD query, and so on. Trying the first approach using search and replace to migrate from the BDE to FireDAC, we can use the IDE's search, find in files, and let's see if we have any BDE T database in our code or forms. We will search for whole words only, and we will search all files in the project. Here we see we have found a few places where we are using the BDE T database in both the data module form and the data module header file. So in the data mod header file, there's really only one occurrence of the BDE T database on line 59. So here we can select the BDE T database and then select search, replace, and we want to replace our BDE T database name with the FireDAC T FD connection, and let's say OK. Replace this occurrence of T database, yes. So now our BDE T database has now become a T FD connection for FireDAC. Next, we need to replace the BDE T database name in the data mod form. We can do that by selecting the T database search item, right-click, edit source, and now we have our form displayed in our IDE editor like this. And here for the form, we can replace the BDE T database with our FireDAC T FD connection. So that's done. Save all. So now as a check, if we reopen our data mod form, we now see that our BDE T database component is now replaced with a FireDAC T FD connection. So that worked great. So we can now continue with this manual search and replace approach to replace all of the BDE names as listed on this webpage with their FireDAC counterpart name on all of our forms and in our code. Or another approach is to use a third-party utility like this Delphi parser BDE to FireDAC migration wizard for C++ Builder. This utility, as described on its webpage, scans your whole C++ Builder project code and migrates the BDE code to FireDAC. Let's now take a quick look at how this utility works. Here we are running the Delphi parser C++ Builder migration wizard for converting BDE code to FireDAC. For the utility, we will select our CBuilder 6 Mast App BDE folder as our source folder, and we'll create a new folder called CBuilder 6 Mast App FireDAC for our modified code. Here are the highlights from the utility's processing. First, copies our project to a new folder. Then it converts our binary form files to text. Then it loads the project files to runtime memory. Next, it scans the code for database objects and references, and then it scans our data modules for database objects. So the utility scanned 8,755 lines of code in our CBuilder 6 Mast App application, and 83 objects were found that need to be migrated. The utility tells us it looked at a total of 8,755 lines of code in our CBuilder 6 Mast App project, with 83 data objects in 56 files. It fixed 144 lines of code by replacing functions param variables, replacing local variables, replacing global variables, replacing objects reference code, replacing class declaration, replacing object modules, fixing environmental code, and adding and removing C++ header files. So now, after you complete your BDE to FireDAC migration, when you look at your new data module form, we now see our new BDE to FireDAC migrated data module, and we see that all of our BDE items have been migrated to use FireDAC. So now, for example, instead of the BDE T database component, we now have a FireDAC T FD connection. Instead of the BDE T table component, we now have a FireDAC T FD table component. And instead of a BDE T query component, we now see we have the equivalent T FD query component for FireDAC. So now we see we have and are using FireDAC components instead of the BDE and all the other FireDAC equivalents from the BDE. So all of this is wonderful. Now, since we made many changes to our forms and code migrating from the BDE to FireDAC, I want to now commit these changes to our Git repository. So I'll select my Mast App executable, right-click, Git, commit. I want to commit from the repository root. So here's all the changes we have made to our project code. Let me add in a comment like migrated from BDE to FireDAC, and let me go ahead and commit these changes. So the commit completed. So now our changes are in our Git version control system for the other members of the team to continue working on this C++ Builder migration.
Since we've migrated the application from the BDE to FireDAC, we can either choose to keep our Paradox database the same, or we can move to a different SQL option. In this case, we're going to make the switch to the Interbase database. Now, Interbase is a highly scalable, powerful, embeddable, and encryptable database that works across several different platforms, including iOS and Android. Something only a few databases out there do while running natively on these platforms. It's extremely lightweight and has a tiny footprint, so you can imagine how quick and powerful it is by not bogging down the system it's running on. It has near zero administration, so you can deploy it and you don't need a DBA to constantly maintain it. As far as moving our application from Paradox to Interbase, there's this nifty little tool called the Interbase Data Pump. It's from a group called Clever Components, and it's going to take any ADO, BDE, or Interbase data source and actually migrate it to our targeted Interbase databases. So it's a free download, and we can take a look here, see the steps, and then download from there. So once you have the Interbase Data Pump open, you're going to go ahead and select the database and then also set up all of your properties. So in this case, we're using the BDE and we're using the DB demos. It automatically popped up on my machine, but in the event that you have other data sources from the BDE, you can go through and click them. You have your username and password, which typically are already inserted anyway. You'll test the connection and make sure that it's passed. Then you can go through and set up any of the properties specifically, so relating to the pump. Maybe you need to disable any of your triggers. Maybe you need to empty out the destination tables before the pumps, or even updating generators. You can also go through the string field properties and building the relationships, typically case insensitive fields and table comparisons. Now we're going to go through and choose our destination database properties. Now, in some cases, if you've already created the Interbase database before this, then you can just toggle through and specifically choose where that database is. If you don't have a database already created for it, you can go into IB console, click on the database, either right-click on this database and create the database, or you can click up at the top of the menu, create database, go ahead and create the database with the title that you want. In this case, I'll be using DB demos. You can go through with the options such as changing the size of the page, also adding in something like embedded user authentication for additional security purposes. You can choose to save the password or even use the alias for database connections. Now we can choose our dbdemos.ib file. We can go ahead and test that connection, and it has passed. Now we're going to want to build out a SQL script for the source so that as we're moving from Paradox to Interbase, it creates the schema script that we just install then into Interbase. So we're going to go ahead and build our SQL script. It's going to save the script to some file, in this case the convertbde.sql. It will rewrite over this additional text file that I already had from another migration. It'll go through and match up with the dialect, any specific character default sets that you may set, and it'll also create the generators for auto-incremented fields. You can choose to add them in manually, so you can add and go through any of the tables that you have and specifically pull in those fields. Or you can also just let Interbase Data Pump create those generators for you. So all of these fields more or less match up as a one-to-one with what Interbase is looking for between the migration from the BDE to Interbase. So we can go ahead and click Start, all fine, and it opens up this converted BDE script, and as you can see, it really just creates the schema for the entire script. So now we can go into our IB console, into the interactive SQL, and we'll be able to add this query, load the entire script, and run the script from there, so that when we have our database created, we'll be able to see that all of the schema has now matched up, and we've successfully moved the schema from our Paradox database to our Interbase database. There's still no data yet, as we haven't actually used the data pump portion, but at least now we've completed half of our database migration. From there, we can click close and go into the order. Now you can grab the definitions, and then from there it gives you these nice 3 steps where you can then build the relationships. So you can either choose to do this manually, Or you can build the relations and it will specifically look at each of these and make sure that as close to matching between the interbase and paradox tables as there can be in terms of data types. You can also do the exact same thing using the generators. And moving on to step 3 with the data pump. I'll go ahead and click start. I'm going to get this message about the destination database is in forced writes mode. This is just because my IB server is currently set to that. So it's going to make the pump a little bit slower. I can go ahead and open up my Interbase Database IB console. In the process of that, I can go ahead and log into my database, and it should be just about done by now. So I'm going to go ahead and see if my data was migrated, and it looks like all of my data for all of my tables, let's check up a couple more, has actually been migrated over. So now I can go into RAD Studio, open up my C++ Builder application, and go ahead and move over to my data module. I can right click on my database connection, set the driver ID to IB for Interbase, go ahead and toggle to my database location, which is dbdemos.ib. I'll enter my username and password. And the sysdba master key for the password are the defaults for Interbase. Can test that connection. My connection has been established successfully. Now we'll go back to the main form where we can then run our application. And we'll let this compile. It shouldn't take too long. A few warnings. And our Mast App application for C++ Builder was able to run. So if we go ahead and click on parts, we can see here that the data is now being pulled from Interbase rather than from our paradox tables. So now we were able to successfully move a database from paradox to Interbase and make that switch as well from the BDE to FireDAC.
One additional item to discuss for this C++ Builder migration is to compare the Borland Classic compiler used in the legacy C Builder 6 Mast App project with the current Clang enhanced compilers we now have in the C++ Builder 10.4 Sydney IDE. The default compiler for C++ Builder 10.4 is the Clang compiler, but C++ Builder 10.4 still also includes the older Borland Classic compiler. You can set the compiler to use from Project, Options, C++ Compiler, and here you see C++ Compilers Win32. Use Classic Borland Compiler is set to false, meaning this project will use the Clang Enhanced Compiler by default. Let's first use the Classic Borland Compiler to build this C++ Mast App project in C++ Builder 10.4 by checking the box to true and save. Let me now build this C++ Mast App project using the older Classic Borland compiler. So it's done, and we see from the messages view we are using the older Classic Borland compiler, the BCC32 compiler, and we see from the build dialog using the older Borland Classic compiler, we have 0 hints, 0 warnings, and 0 errors. So that's fine. So we see that the project built just fine using the Classic Borland compiler with no errors. And we can also run this Mast App application built using the Classic Borland compiler. And it runs just fine. Next, let's build this project again, but this time we'll use the Clang Enhanced compiler. To change the compiler, once again we use Project, Options, select C++ Compiler. So now instead of saying use Classic Borland compiler set to true, We will uncheck the true, making it false. So now, instead of building using the classic Borland compiler, the project will build using the new Clang Enhanced compiler. Click Save. Let me first clean the project to remove any old Borland Classic compiler files. Now let's build the project, but this time using the newer Clang Enhanced compiler. We see using the newer Clang Enhanced compiler, it takes longer to build than it did with the classic Borland compiler. Here we see from the messages view that we are using the newer current Clang Enhanced compiler, the BCC32C, and the C tells us we are using the Clang compiler. This time, using the newer current Clang Enhanced compiler, the BCC32C, we see that we have 0 hints, 0 warnings, but 4 errors. And looking at the 4 errors, they are all coming from our data module. So the first error is value of type int is not implicitly convertible to a DataDB tlocate option. So here we see that the newer Clang Enhanced compilers are stricter than the legacy classic Borland compiler. You have heard me say that C++ Builder 10.4 features Clang Enhanced compilers. So what do we mean by enhanced? Looking at our DocWiki page for C++ Builder 10.4 Sydney, Clang Enhanced C++ compilers, we see that C++ Builder 10.4 includes 6 separate compilers. We have a Win32 Clang Enhanced compiler, another Win32 Clang Enhanced compiler that uses Clang command line flags, making it compatible with other Clang-based compilers, a Win64-bit Clang Enhanced compiler, an iOS ARM Clang compiler, an iOS ARM 64-bit compiler, and an Android ARM compiler. The C++ Builder 10.4 Clang Enhanced C++ compilers are based on the open source Clang project, which means they are an entirely new code base benefiting from the input from hundreds of developers. We extended them ourselves with support for the language features we offer, such as properties and other features that work in our ecosystem. And that's what we mean by enhanced. The C++ Builder 10.4 Clang Enhanced compilers offer many significant improvements compared to the previous generation C++ compilers, such as the legacy Borland Classic compiler, the BCC32, the 32-bit Windows compiler. For example, exception handling is much more robust, the language standards is much better, supporting C++ 17 on Windows, whereas the older Borland Classic compiler only supports C++ 03, which is 17 years old now. With the C++ Builder 10.4 Clang Enhanced compilers, you get much safer coding. Using the new, safer, and more expressive C++ features, you get faster performance for compiled code. Our C++ Builder customers have reported up to twice as fast runtime performance just by rebuilding with Clang, and many more specific features using Clang. And just to name a few of the notable differences between the C++ Builder 10.4 Clang Enhanced C++ compilers and the 2 previous generation C++ compilers, the C++ Builder 10.4 Clang Enhanced C++ compilers are also preprocessors when run with the -E switch. And for 64-bit Windows, there's also a separate CPP 64 executable preprocessor. The C++ Builder 10.4 Clang Enhanced C++ compilers enforce template two-phase lookup. The Clang Enhanced C++ compilers allow a default argument only in a function declaration. The previous generation C++ compilers allowed default arguments in a function pointer or closure declaration as well, plus many more enhancements that are listed on the C++ Builder DocWiki page here for differences between the Clang Enhanced C++ compilers and previous version C++ compilers.
So let's have a look at the help section of the app. I've got the source code downloaded here and the Mast App help file, which I've copied now onto my desktop. If we try to double click and open this up, we can see it takes us directly to the Microsoft website, where it tells us about the error opening help in Windows-based programs. And this is a format that is no longer supported on Windows 10, and in fact hasn't been available for many versions of Windows. If you are encountering this version issue, then what you can do is either re-export using your existing help program, or you can use one of many applications available to import and then re-export out the help file into the new format that is supported on Windows 10. So I had a quick search around. I managed to find Help NDoc, and they've got a free evaluation purpose version, which is great, ideal for testing. Obviously, if you do want to use it commercially, then there's a price to pay for the commercial version, a couple $100 or something. So you know, a pretty cost-effective way to go rather than having to rebuild the whole help file. So let's have a quick look at doing that. So I open up the Help NDoc here, and I'm just going to go File, New Project, and we'll call this Mast App. And I'm going to create an empty project here. And then what I can do is import in our existing help file. So this is why I put it onto the desktop to make it very easy to locate quickly. And let's import that in. And we can now see that we've got our content in here. Now, the one thing I will say, just from past experience going through this, you do need to go and make sure that you set up the line spacing, just check any line spacing issues, and then generate the help file. So I'm just going to go here and let's just change the paragraph here, and instead of having it at 16 points, I'm going to set this to at least a single line. I'll do that on all those and then just export out. Okay, so now the paragraphs are all set up, and the thing about using line spacing compared to font weighting is that Windows 10 obviously has multiple different resolutions and different things going on, and it just means that you'll get a cleaner help file. So let's go generate the help out, and I'm just going to generate the CHM. I don't need all the other versions here. And there we are, we're done. So let's go and have a look, and we should now have a help file that we can open up and we can see content in. Let's just work our way through here. Looking good. Right, so now we've got a help file. Now we need to make sure that it works with the same calls on Windows 10 as it has done in the past in our app. So I'm just going to take a copy of this help file and pop that on my desktop for now, just so I don't lose it. Let's close that. And let's jump into Rad Studio. Now I've created a new project here, and I've added into the project the main CPP file, form and the header from the previous application. So let's have a quick look on the form here. And we have a look at the code behind the help button here. We can see we've got this application help command help context of 0. And if we have a look at the actual main application CPP file, we can see in here that the help file is being set as the application starts up. So let's just go ahead and we'll copy that, and that's pretty much it. So let's see if we can now get this to work in a new test application, just to make sure that all the help file context is working before we merge that into the main branch. So I'm just going to create a new VCL C++ application. I'm not going to save the changes to this project here. And we're literally just going to put down a single button. And into there we'll paste in that. Oh, that's the wrong part of code. It was application help command, and it was help contents. .0. Okay, so that was the command to launch the help. The other thing we need to do is just tell it what the actual file is called. So if we go to have a look at the project source, in here we should be able to now paste down the other line of code. And let's update this to the CHM file that we have got. So the other thing we need to do now is we just need to save the project. And the reason we need to go to save the project, and I'm going to put down a new folder in here, 007 help. The reason we're going to save the file, or save the project should I say, is that at the point that we build this for the first time, the project will then create the folder structure for the output. And whilst we're doing the testing here quickly, this is on a debug version, so Debug Build. We've got the Debug Build configuration, so let's just go Show in Explorer. We can see in here we've got the Win32 debug, and then there's our project. So if we try to run that at the moment, it will not find the help file because the help file is not there. So let's just go and move this now into our folder. Now if we launch our application, we can now see that we've got this unable to find table of contents. Okay, so this is actually quite an easy one to fix. Because the CHM is based on HTML, we actually need to just provide a couple of additional lines at the point that we launch the project. So in the top section here, I'm just going to copy this, and we're going to include it's VCL.html help viewer for HPP, and then we just need to set pragma package smart initiation, and then also one more pragma. We need to link the VCL HTML help viewer. Okay, so this will initialize the HTML help viewer within the application, and I think that's all we need to do. So let's go ahead and build and run. And now we can see that we have our help file opening up, which is brilliant. So we're now ready to kind of integrate these modifications into the main branch and use our help.
We've gotten to the point in our migration process where we're wanting to update the UI and give it a more modern look and feel, such as adding Windows 10 styling, or even being able to take advantage of new Windows 10 features such as high DPI on multiple monitors. With Windows 10 UIs, they need to be able to scale according to the DPI of the target monitor. And when you have images or other graphical elements that aren't scaled properly, they can look blurry too small, or even too large in some cases. During our planning meetup, we discussed a few things that we wanted to change. So the first thing that we're going to change is the icons on these T-speed buttons. They look a little bit outdated, and we want to give them a more modern look and feel. Now, if I go ahead and I run this application, we can see right off the bat that there's definitely an issue with the sizing of the images and the other graphical elements within the application. I'm running a machine that happens to have 2880 by 1800 for my screen resolution, so the images that we have here are quite small. So that's going to be the first thing that we go through and change. With RAD Studio 10.4 Sydney, you're able to include some scaling high DPI multi-resolution images in your VCL applications. And you do this by using two specific components, the T image collection component and the T virtual image list. When paired together, you're able to load multiple resolutions of the exact same image into the image collection here. And then the image list holds the set of images from the image source itself. The image list holds a set of images that are then sourced from this image collection and then presents them at a specific size, say 16 by 16 or 48 by 48. Now the images are then smoothly resized and scaled, and the image list's actual presentation resolution is then changed based on the DPI of the target machines. So there's this great website called Android Asset Studio that is, as listed, a collection of tools that easily generate assets such as launcher icons. In this case, we're going to look at the launcher icons. Now, one of the cool parts about this is that it'll take an image, it'll take clip art or even text, and it will actually create them at different screen resolutions. So for instance, 16 by 16, maybe 48 by 48, and it'll actually create them so that you can download them as the pre-packaged resolution, so that when you want to add them to projects, you don't have to worry about how an image is going to look, if it's going to be blurry versus clean and crisp. Moving back into our image collection list, I'm going to go ahead and show the image collector editor. So I can just go here and click on Add. And I can go through each of these, and you'll see here that the icons show up under selected images as different resolution sizes. So as I add in more, you can see they're matching up with the name for each of these icons. So I've got a 72 by 72, 48. I'll go ahead and just add in the rest of these real quick. And we now have icons from 48 to 192. If I go ahead and apply those, then I can move into my virtual image list. Now, if I set my virtual image list to the image collection, then I can open up the editor for the image list and then add in the icons. So I'll click OK, and now it's resized my icons under the selected image. Next, I can click on my T-Speed button, find the images, choose my virtual image list 1, and also the name of the image as how it's listed in the T virtual image list. If we run the application again, then you'll notice that the image has now been resized properly compared to the rest of my images. If we close out, we can go ahead and do the same thing with the rest of them. I already went ahead and added all of the 5 icons that I will be replacing. They all have the same pixel size, so no variation there. You can go ahead and click OK. Now going into the virtual image list, I can go ahead and add the rest of them. So I can say select all, can click OK. And now through each of the parts, I can actually go through to the images, add the virtual image list, and choose for each one of them. So for new order, we'll choose new order. For browse, we'll choose the search. And then for parts, we can use list. So we've now been able to update each of the icons. So if we go ahead and run the application again, then we can see that the icons themselves are very crisp and clean, and they also are scaled properly to the size for the rest of the application. Now, if we move into Browse, there was one other section that we really wanted to work on, which was defining of the calendar range. So this calendar looks quite old and outdated. So we're going to go ahead and replace it with the T calendar view that we have as part of Rad Studio. So we'll go ahead and close out and open up our pick date file. So we're going to expand out the form a little bit so that we can see a side-by-side comparison of the calendar view with the current calendar that we have listed out here. So from this calendar, as we can see, it seems like it's a little bit more outdated, while the T calendar view was actually designed for Windows 10. So it gives it a more modernized look, like you would expect from a Windows 10 application. So we're just now going to remove the components from the older calendar set, and we then will also change a little bit of the code in the back end because a few of the procedures and components will no longer be there. So the cancel still stays. The next month, that's actually pre-built into the Win10 T calendar view, and we can get rid of the previous as it's also located there, and the title label as well. Now we'll just go ahead and reposition our new T calendar view on our form. Give this a little bit more space here. And then shrink back that form. Now we're going to go into the pickdate.cpp file first, and we are going to change and remove a few components and properties. Now, since we no longer have the calendar, but we do have the calendar view one, I'm just going to add the word view into my calendar. Now, calendar view does not actually have a calendar date as a property, but it does have date as a property, so I'm just going to remove that. I'll do the exact same thing as I did up above, remove the calendar and add the word view. Now, we ended up getting rid of the previous and next buttons along with the title label, so we're actually just going to remove them in our CPP file. Next, we'll go into the pickdate.header file, and we're going to end up getting rid of all three so that we don't run into an error there. Now, if we go ahead and run the application, and now we should be able to go and build our application. And now we have a running application with both new icons and a Windows 10 calendar. We've successfully run our Mast App application using the 32-bit Clang compiler, and now we want to run it using the 64-bit compiler for C++ Builder. So our first step is going to be to expand out our target platforms and activating the Windows 64-bit targeted platform. Now we can go ahead and run the application, and we'll see if or what changes need to be made. As you can see, we have a 64-bit version of the Mast App application up and running. If we go into our project folder, we can then see that a Win64 folder was created under the debug configuration, and under there we can see that we have our C++ Builder Mast App application available.
Okay, so we are almost at the end of the webinar now, and we've got all the main work done. So I thought it'd be just a useful thing to recap and have a quick look at the app now and also at the start. So we see the start one on the right-hand side there. The icon's been quite small, as we predicted with the move to Windows 10, that was going to be a challenge. And on the left-hand side, updated, all looking good. Should we delve in and have a quick look around? I think one of the other app modernizations was the calendar control as well, wasn't it?
Mm-hmm. You can see here we have the new Windows 10 VCL styling, and we can also open up the older version as well. You can see a nice big difference here.
Yeah, the animation just makes it a much nicer and smoother control to use, doesn't it?
Yes, very much so. I have a little bit more range also with choosing dates as well, compared to having to click 100 times just to get to 1990.
Yeah, and I think one of the other things that we could also have done here, there's obviously the calendar drop-down controls that we could actually replace that bit. Instead of popping up a separate form, actually have the control all embedded in as well. So there's a number of nice options that we can pick up and take there. Okay, cool. And the help file's working, obviously, as well, which wouldn't be with the old version, which we've seen the issues with as we've gone through. And the database, obviously, we're now working on a 64-bit version, which we're able to use with Interbase as well. So some great modernization wins all around. Al, anything else that you want to kind of add in as a quick summary at the end here?
Wonderful. So during this migration, we got to look at the main items to consider migrating a legacy C Builder app to the current version. So basically, we looked at third-party libraries and components. We looked at any Unicode changes you may need to make if you were running a version of C Builder prior to C Builder 2007. We looked at the data access components, specifically, if you were using the older Borland database engine, to get off of that to a newer, more modern data access component like our FireDAC component. So we showed you how to migrate off of the BDE to FireDAC. Next thing we looked at is switching from the classic Borland compiler to the client compiler, a much more modern C++ compiler with greater optimizations. And then finally, we got to look at some new UI modernizations to make the application look more new and more modern. So all in all, migrating a legacy C Builder app to the current C Builder is a lot easier than anyone thinks it can be.
No, absolutely. I hope you guys watching have found this useful. Mary, anything else that you want to kind of say at the end here?
Just good luck in your upgrades.
Yeah.
And Embarcadero is here to help.
Absolutely.
Yes.
Every step of the way. If you need us, then please remember we have our professional services available who can help you with the migration. But there's also the Upgrade and Migration Center with a lot of key resources online. So please use that as a start place. And but if you get stuck, we're here. So happy coding, everyone. Thanks very much for joining us, and see you again soon.
All right. Thank you.
Thank you.
Hello, good morning, and welcome to day three, I guess, the European is 3, of DelphiCon 2021. I'm Jim McKeith. Today, this morning, we have David Millington's session on using C++ to extend the reach of Delphi. Always learn a lot from David's sessions. He does a great job. So with that, I will turn it over to David, and he'll take it away.
Awesome. Well, thanks, Jim. We'll just turn on my camera as well, so that hopefully you can all see me.
I see you. You look great.
Fantastic.
Dapper
Thanks.
as usual.
All right. Well, hi everyone. I'm Dave Millington. I'm a senior product manager here at Embarcadero. Now, normally with these webinars, we try and pre-record them, but I'm doing this one completely live. So hello. Look, today we're going to talk about using C++ to extend your Delphi app. Now, for those of you who are wondering if this is familiar, I actually did a similar talk in 2016, 5 years ago now. But this time I'm actually going to show a bit more than that one did. I'm actually going to pull in an open source C++ library from Get and make use of that. So I'm going to show code that where you have an existing Delphi app and we end up using an open source C++ library with your Delphi app. So Delphi and C++ Build are fairly rare in that they can interoperate at the binary compiled level. You can build a single application using source code in 2 languages. Now, before expanding on how to do that, I think it's worth asking why. Why would you build your app out of 2 languages? And a programming language is called a language for a reason. It's a way to communicate and to express intent. And the way that a language is designed makes some languages better for some purposes than others. Some are good at data processing, some at writing algorithms in, some at being easy to understand or to read, some at connecting to user interfaces, some at being efficient or performant, and so forth. And that means that you can choose the languages you use based on your intent. But the key is that you're not limited to one language and that you can mix and match languages based on your purpose at the time. So Delphi is an example of a language that's very clearly written. It's expressive and great for connecting to UIs and very easy to understand when you read it. Now, C++ is a language that's less easy to understand when you read it, but very good at performance, and it has a lot of open source libraries for a huge variety of functions. And mixing the two lets you write most of your app in Delphi, but bring in some of the C++ compiled performance or some of the vast number of C++ libraries that are available. So in this talk, we're going to see one technique to call into C++ from Delphi code. And the technique I've chosen is my personal favorite. I've chosen it because from the Delphi side, it feels very Delphi-ish. And we're going to use, as I mentioned, one of the open source C++ libraries and get it to speed up some Delphi code by rewriting it in C++. So before getting onto that, I want to show a little bit about binary compatibility. Also, I can see that macOS is sharing its dock and title menu bar at the moment, and apologies for that. I have no idea why, because it should be auto-hidden. Look,
Actually, we don't see your screen right now, David.
You don't see my screen?
Nope.
All righty.
Now we do.
How about that?
Yeah,
we just went through a wonderful slide on choosing languages with different languages suitable for different purposes, and the slide just said that we're going to see how to call into C++ from Delphi app. This slide, I think, is really key, though, and so I'm glad that that we have the slide visible for this. Look, the key with calling between languages is binary compatibility, and that takes a few forms. There's object file compatibility. For example, there are different formats of your intermediate compilation files. What the compiler emits goes to a file, an object file, and that's linked into your final executable. For example, on Win64, C++ Builder uses ELF64. or the application binary interface compatibility. So I want to explain as well the difference between an API, an application programming interface, and an ABI, the application binary interface. So the API is the most common term, and that's the programming interface. And that's where you have a set of methods or an interface or something like that. And effectively, that's an interface that's defined for you, the programmer. It lets you know what methods are available for you to call. Or it lets you know some of the language semantics, that a method parameter is const and you can't modify it, something like that. The ABI, the application binary interface, is where things get interesting, and that's where things like calling conventions are defined. So you might have a statement like, any value type less than 8 bytes in size will be directly placed into a register, but if it's greater than 8 bytes in size, the register contains a pointer to its location. Its usage semantics are as a value, even if under the hood is accessed by pointer or reference. And now that would be an example of the kind of statement you might have backing the actual binary interface. And really what that is it's saying how the API is implemented under the hood. So the ABI is what means that these two APIs, you can see a method declaration on screen, the top line in Delphi and the bottom line in C or C++. So those are one API expressed in two different languages, and the ABI is what means that they are the same. Which means that at a linker level, or when loading a method and calling it by its address, they are the same. The way the parameter is passed is the same, and so forth. And you can apply that to a whole class declaration as well, or an interface. Now, Delphi actually auto-translates Delphi APIs to C++, so it performs the translation that you can see on screen right now, obviously not just for methods, but for all type declarations, your classes and enums and everything else. And that translation is one of our studio's key features, and it's what lets us write components like buttons or an edit control or something in Delphi and have C++ developers use them. But we can also leverage it to help Delphi developers access C++. So you may be wondering if we can just write C++ code and have the compiler translate the API to a Delphi unit so you can add that to your users clause. And unfortunately, the answer is no. 99% of Delphi can be represented in C++, but not the other way around. C++ has many things that cannot be represented in Delphi code. But we can still use this Delphi to C++ translation to access C++. So here's how we do it. Well, one way to do it. This is my preferred way. First is we write an interface or an abstract base class in Delphi. Now, using the C++ translation, C++ Builder can then implement a class that inherits from that Delphi class. And then in that C++ class implements whatever needs to be done in C++. And Delphi talks to the C++ code as though it is Delphi code using the Delphi interface that it knows about. So to run through that again, we make use of the compiler translation, and the same thing can be represented in two languages. To write an interface in Delphi, implement it in C++, and speak to it as though it was Delphi. Now, there are other ways to do it. You can flatten to a plain old C API, you can use COM, there are all sorts of things, but this is my personal favorite way because it makes use of the inbuilt Delphi C++ interop. And it means that on the Delphi side, you address the code as though it is written in Delphi. So that's sort of the theory behind it. But I want to actually, of course, go through this in practice. So I'm just going to turn off my camera now so that we can focus on the screen. Alrighty. So hopefully you can all see Rad Studio right now. Now here in the IDE, I have two projects. Now one is my existing Delphi app. That's the one that's selected right now. And I want to add some C++ to it. I'm going to do this by putting my C++ in a package. Now you can put it anywhere in a DLL. You can even put all your Delphi and C++ code together, .pas files and .cpp files in one C++ builder project, although it's not ideal if your app is 99% Delphi. But following from the idea, which I think is common for many people, that you have an existing Delphi app and you just want to add a bit of C++, let's quite literally do that. So we have a Delphi app and we're going to add a C++ package to it. I also think this is quite architecturally clean. So in my Delphi app, I'm going to define an abstract base class. So you can see that definition here. I have a T-abstract class. And all the methods here are virtual abstract. So this class has no implementation at all. It is very similar to an interface. And it has all the properties and methods that I want to use. And you can see how it has a property here and a procedure here, and here are the property getter and setters and so forth. Now I'm using an abstract base class as a type of interface since I can just inherit from it. Now if you want, you can use an actual Delphi interface and the compiler will translate that, so you can implement the Delphi interface in C++, but personally I think that the abstract base class here is simpler. So first let's have a look at how this would work using Delphi from Delphi. And then we'll do something very similar from C++. So I want to demonstrate the Delphi version first in order to make the C++ technique clearer. So in Delphi, we can inherit from this abstract base class. So I have a Delphi implementation unit here. And you can see I have a T-Delphi descendant. Actually zoom in the code a little more again. Delphi descendant that inherits from my abstract class. And you can see I've implemented the various methods that are required. So you can see here, for example, I have the property getters and setters and a method that does something, which is just going to show a message box and so forth. I also have a method to math stuff, which I'm going to get back to later when we come to the optimization section. The Delphi math here just gets past a massive array of numbers, and then it does some math operations, mostly square roots, because square roots are fairly famous for being expensive math or slow math. The point here is to demonstrate some kind of mathematical operation that is implemented in Delphi that you might want to optimize. So this is pretty simple. We have a Delphi abstract base class, and then we just inherit from it again in Delphi. Now I also have a method to create an instance of that class. Just have to remember where I put that. Here we go, create Delphi descendant. Now you notice it returns a T-abstract class. That's the abstract base class. So we're using polymorphism here to hide the fact that there's a derived class. We're just accessing via the ancestor abstract interface. So our code doesn't care how the abstract base class is implemented. And this is key. Our code doesn't care how the abstract base class is implemented. It just cares that it can call the methods that are defined and something will happen. And so here I happen to create a Delphi descendant and it will return that. Now in this app, I have a button here to call Delphi code. All this does is creates my Delphi descendant and then does stuff with it. Here is my do stuff method. You can see that it creates a large array and fills it with sort of random numbers. And it also accesses a property. This is a text property. I'm going to set it to the text set from Delphi, and then I'm going to call a method called do something. And that do something method is the one that showed a message box. So I'm going to ignore the math one for the time being, but I just want to demonstrate this right now. So if I run this and I click the call Delphi code, you can see that we get a message box that says hello from Delphi, and the property that it's reading has the value set from Delphi. So I hope the technique here makes sense. We have an ancestor class, we derive it in Delphi where that drive class does useful stuff. And in our Delphi code, we get an instance of that, we call methods on it, free it, it's easy. Okay, so that's our model, our model. We have a base class derived from it and call methods on it, and we saw that in Delphi. Now, due to the translation and ABI compatibility, we can do exactly the same thing in C++. We have our Delphi base class, and we can derive from it, but this time we derive from it in C++. And then we can call methods on it from Delphi. So this is all in the C++ package. You can see I've added the Delphi unit here. Because this is a .pas file, when you build the C++ package, all the Pascal units are built first before the C++ ones. And that's because the compiler will automatically generate a translation of what in Delphi is the interface section, of the various types and so forth, and creates a C++ header containing that information, which you can then include in your C++ code. So let's have a look at that. So this is our Delphi abstract class unit. This is the one where we defined the abstract class. Now that gets compiler translated to something that's honestly fairly ugly looking, mostly because it is compiler translated. I'm going to scroll here so you can see the key part here. But even if you don't write C++, you can probably understand the structure of this class. It's got the same properties and methods, although it's written a bit differently. Now I won't dwell on this too long, since C++ syntax is the kind of thing you can pick up from reading it or from reading a book on C++, but it basically uses squiggly braces instead, and some things are written in a different order to Delphi. For example, the virtual keyword goes at the front of the method declaration, and it's an abstract base class, a pure virtual in C++ terms, because of the equals 0 at the end, which says, hey, this method is declared, but it has no implementation. Different syntax, but it means the same thing, which is a bit of a key to the stuff I'm saying today. So what we do there is, in our actual C++ class, we have our header, and the header in C++ is the equivalent of the implementation section in Delphi. This looks a lot cleaner here, I think, because I'm just deriving from the abstract class. So again, C++ syntax is different, but I think you can probably understand that we have a class declaration. This decl spec here says that it's a Delphi style class. I'm calling it a TCPP class. It inherits from the TAbstract class, which is our Delphi class. And you can see that I have methods here, like a method do something and the method do math stuff, which are the same methods that we had in the Delphi abstract class. Now, one thing that's interesting is that in Delphi, the do math stuff method just takes this array of single or array of float as a single parameter. Now, when it's translated to C++, most things when they're translated to C++ from Delphi come across exactly the same. So you can see here that I have a set text method, which is the setter for my property, and it has a Unicode string value, which is, again, the order of how you write the parameter values and types is different, but you have a method with one parameter, and when it's translated, you get one parameter, which is what you expect. Now, do math stuff is different. In Delphi, it had one parameter, the open array. Now, C++ doesn't have the concept of that same type of array as Delphi does, so it gets translated to a pointer to the first element, and then a second parameter of the number of elements in the array. And this is actually how it's implemented under the hood in Delphi as well. It's just that the language hides that. You don't see that. But I think this is interesting because it's because it's an example of one of the slightly unusual translations that you can get. Anyway, that's the interface in Delphi terms, or the header declaration in C++ terms. And again, I just want to emphasize here that we're doing the same thing in C++ that we did in Delphi. We're just creating a C++ class that inherits from the Delphi class. So let's move to the implementation. And in C++, instead of having interface and implementation sections of the unit, you have a header file and a C++ file. So that's what we have here. I'm just going to scroll down so you can see that we have our getText and setText methods. I'll scroll past that so that we have our doSomething method. And just like the Delphi one, we have something very similar where we end up calling a message box. Only this time it's going to say hello from the C++ class instead of hello from Delphi. Alrighty. Look, there's one final missing piece, which is getting the C++ class back to Delphi. Now, if you remember, when we did this in Delphi, let me scroll here, here we go. We have this method, create Delphi descendant, and that returns a T-abstract class, but it actually creates an instance of the Delphi descendant. Now we want something very similar for our C++ class. And so what we're going to do is we have a method here that is implemented in the C++ package called create CPP descendant. Now here's the Delphi equivalent of that. So function create CPP descendant returns a T-abstract class standard call, and this external keyword that is calling convention, this external keyword says that it's loaded from this particular package. We translate that, and remember that this is keeping the same API but expressing it in a different language, but it means exactly the same thing. That we have a method that returns a T-abstract class pointer called create CPP descendant using the standard call calling convention. And while Delphi says that we're loading it from the C++ package, we're going to say that we export it. That means it is available to be loaded. And all it does is create a new instance of our C++ class, which is the equivalent of Delphi creating a new instance of the Delphi class. Then back over in the Delphi app, you remember that we had these two buttons called Delphi code and C++ code. If we go to the C++ code, it just calls create CPP descendant. Let me show you where that's actually defined. This is the actual line of Delphi code that I showed commented out in the C++ side before. So Delphi knows about this. It knows there's a method called create CPP descendant. It knows it should load it from the CPP package. So here we just call that, and then again we pass it to the same method, do stuff that we did before, which set the property and call the do something method. Only in this case, the instance that we're going to get is our C++ class, and the do something method is going to show a message box saying hello from a C++ class. All right, let's run this and see what happens. It just takes a moment. Okay, so we have already seen this where we call Delphi code, and if I click the Delphi button, you already know what happens. It shows a message box, hello from Delphi. And then here we're doing the same thing. The second button, call C++ code, and here we get another message box saying hello from the C++ class. It shows the value of the property. That property is implemented in our C++ class, but it has the value set from Delphi because our Delphi code set it to that. And a bit of other text that I put in that just shows using some random C++ stuff. So there we are. That's the basic technique. We have the keys that you can call or that you can write Delphi code that behaves as though it's calling a method or setting a property on a Delphi class. and your Delphi code can be completely unaware it's actually implemented in C++. Now, if you have a large dev team, you may have some people on your team who don't want to learn C++, and that's fine. You just need one person who's interested, and the rest of your team doesn't need to worry about it, because the code that interacts with whatever you implement in C++ is written in Delphi. And once you can call C++ code, you can write anything you want in C++. So what we have now is the bridging mechanism. We got a C++ class, and we can write any code we want in that, in C++. So remember how at the beginning of this talk, we were talking about how different languages are good at different things. Now, C++ is good at optimization, and it's good at having a lot of open source libraries to take advantage of. So I want to have a look at both of those right now. So back to Delphi and my Delphi implementation. Now I have a Delphi method here that does some math stuff. I briefly covered this before, where we pass it a very large array of numbers, and then it just does some math on each entry in the array. This is very meaningless math. I basically just wrote it because it's the kind of thing that can take some time to calculate. Basically, we want to try and optimize this using C++. Back in my Delphi code, I already showed calling the do something method. What I'm going to do now is comment that and uncomment this code instead. So I'm going to use a stopwatch to measure how long it takes to call do math stuff. And then I'm going to show a message box with that information of how many milliseconds. So let's run that right now, and we can see I have a very big array here. You can see how large it is. And so we're going to cycle through that 3 times, doing various math on it. And we're going to measure using the stopwatch how long that takes. So let's run that right now, just the Delphi side, and we can see how long it takes the Delphi code there. And this is Windows 64 bit, it's built in release mode. So I click the Delphi button, and the math items took 207 milliseconds. So 200 milliseconds to do all of that math. So the question is, can we leverage C++ and leverage, say, an open source C++ library to do better? Well, let's go to the C++ class. Now, look, first of all, I could just directly translate that to C++ as I've done here. And I think that's probably very readable because it looks fairly similar to the Delphi code. And that will already give some very good performance. But what I really want to show is not just writing C++, but using an open source C++ library, mainly for the sake of demonstrating that you can use an open source C++ library. So if I go to get it, now I have already installed a C++ library called libsimdpp. Let's just take a moment to load. Perhaps a couple of moments, I can grab a mouthful of tea. Alrighty, so loading the C++ libraries. There are quite a few here. If I scroll down, there's one here called libsimdpp, and it's a portable, zero overheads, low-level C++ library, which is for math optimization. So I've already installed that, and so now I just need to show you how to use it. Installing, by the way, from Get is the same as in Delphi. You just click the install button, and it will download and install for you. Now, look, to use this library, all I need to do is include the header at the top. That in Delphi is like adding something to the users clause. Now, this particular library can optimize math to various instruction sets, like SSE2 or SSE 4.1 or AVX or AVX2 and so forth. You choose which to use by defining a macro before including the header, because the header, which is the same as using a unit in Delphi, because the header behaves differently depending on the value of this macro. Now, I've never used this library before, so it was fun experimentation. I actually found a small bug while doing this, by the way. So we should be able to define here to use, say, the AVX instruction set, which would be nice because we get some really good optimizations there. Now, unfortunately, in 11.0, we don't ship all of the headers we need to do that. There are a whole bunch of intrinsics that directly map to various assembly instructions. We're missing a couple of headers for the very advanced, very modern intrinsics like AVX. So I entered an internal bug for that, and we should hopefully ship them in 11.1. So for this demo, I'm just going to have the library optimized to SSE2, which is actually the default instruction set that we use for math in C++ Builder 64-bit anyway. And we get some very good optimization. Go ahead and try this in 11.1 when we actually do ship the other headers, and you can modify this to, say, use AVX or something like that, and see how much better we can get it. But we're going to see a huge performance increase anyway, just using this compared to the same code in Delphi. So let me scroll back down, and let me just quickly go to the Delphi implementation, just to remind you of what it did. It looped through the vector 3 times, and the first time it calculates the square root of each element of the array. The second time it squares the element of the array and then multiplies it by 2. Then the third time it does a square root again. And again, this is fairly meaningless math, just chose it because it's the kind of math that can be slow. So let's have a look at the implementation using this particular library. Now, this library is meant for using the vectorized math instruction sets like SSE and AVX and so forth. And so this translation is quite long compared to the Delphi code because the C++ library is I don't know, I guess a little abstract. It has the very basic building blocks that you use. So as I note, I haven't used this library before, so don't count on the translation being completely right. But I looked at some code samples online, and I believe it is. And what we're doing is that instead of going through the array one by one, we're going to calculate and vectorize it 4 elements at a time. So you can see here that my for loop increments by 4 instead of incrementing by 1. So every time we go through the loop, it'll increment, jump ahead by 4 instead of by 1. And each element through the loop, we have a structure here that will load 4 elements of the array, 4 floating point numbers. So we load 4 at a time. Then we call square root on it using this library's version of square root that can handle calculating that for 4 elements at a time. And then we store the result of that back in the array. And we do the same for the other operations, to square and multiply by 2, and then of course to square root again. So you can see here this library is very decomposed. It provides very basic building blocks. But the thing is, these building blocks are intended for vectorization, for operating on multiple bits of data at the same time. But you can see, though, in spite of that, that it does the same thing as the Delphi code. Alrighty, so let's run this. Let's take a moment to compile. Looks like I changed enough, it's completely rebuilding. Alrighty. By the way, I have my project set up using dependencies. so that when I try to compile or run the Delphi app, it will automatically compile the C++ package first, which is a neat feature that we have. You can just access it by right-clicking in the projects menu and accessing the dependencies item here, and you can set up the order of compilation for multiple projects, so that if one project depends on another, the first project is always built before the second one. However, so just a reminder of where we are. We have our C++ class inheriting from our Delphi abstract base class. We have some math code in that. That is a translation of our Delphi math code, and we are using an open source C++ library called libsimdpp that provides vectorization primitives that allow us to highly optimize the mathematics code. Pardon me. Just a reminder, we'll call the Delphi code 213 milliseconds. Let's call the C++ translation of that, and took 35 milliseconds. Now that's a very decent speed up, let's say 8 or 10 times faster. All right. So what did we just see? We implemented a class in C++. Our Delphi app speaks to that C++ class as though it's Delphi through the magic of our compiler translating the declarations and the ABI magic. Now that C++ class can use any C++ at all. This is the real power of it. Once you cross that language barrier, you're not restricted to writing Delphi-ish C++. You can write any C++ at all in your C++ class. And we used a third-party open source C++ math library. So we added C++ to our Delphi app. We used an open source C++ library, and we optimized our Delphi math code to get, let's say, about an 8 times speed up. That's really not bad. All right, so this is a new version of code from Code Rage 2016. There's the link there. I haven't pushed the new code back yet, but I will very soon. We have 20 minutes left, so let's move on to a live Q&A. I hope it was useful, and I hope to see many of you who use Delphi taking advantage of the strengths of 2 languages. Before we move on to the Q&A, I just want to point out you're always welcome to email me. I read every email that I get, and I try to reply to all of them as well. But I can guarantee that if you email me, I will read it. So with that, let's move on to the Q&A.
Okay, I'm here. Sorry, trying to upload everything for next sessions.
No worries.
Question.
Well, hi again, everyone.
Hello. It's like you were just talking to us.
Yeah, amazing, isn't it?
Does mixing of Delphi and C++ does work in general too, which means under iOS, Android, macOS, and Linux, or is it only for Windows?
It works for every platform when we have a C++ compiler. So for example, we have iOS and Android 32. We don't currently have macOS. But if you have a C++ builder on that platform, then yes, this technique works on that platform. That's one of the things about C++ builder. This is how it's built. It always will work.
Now, we're also asking, is it relies on BPLs? Do you have to deploy the BPL, or is the BPL linked in, or what does that mean?
Yeah, look, in this one, I linked with the package at runtime, so you would deploy the BPL. I mean, to me, I find that cleanest. It's how I would recommend doing it. I mean, there are other ways to do that, but that's what I would recommend. So yes, you need to deploy that BPL using this technique.
Okay. So there's a question about replays. We are working to get the replays posted right as quick as we can. They should be available in perpetuity for attendees, but can't guarantee forever. So do watch them as soon as you can, but we're working our best to get them up there. We're not planning to hide them from you at some point. A lot of people commenting about how useful this is for them. That's great. Are you planning to share your source code?
I'm sorry, I was muted. Absolutely, yes. So there's an early version of the source code from 5 years ago that will get you started straight away at the link on screen. But I pulled that source code and just made some modifications to it yesterday. So I will, commit that back, push that back later today or maybe tomorrow. The only difference is that the code in 2016 used this just to show a message box, and I extended that this time to actually use another C++ library. But the technique just of jumping from Delphi to C++ by itself is already there on that link.
Yeah, it's interesting. Reprising a session you did from 2016. It's one of those things that in my mind, a lot of times I'm like, I did a session on that. I don't want to do it again. But then I find if I do it again and I add new things to it or enhance it or whatever. And then also, I mean, clearly a lot of people hadn't seen this before because they're like, oh my goodness, I've been wanting to figure this out forever. So thank you for doing this again. I appreciate you revisiting this for sure.
Well, it was 5 years ago, and that's half a decade, which is kind of surprising in a way. And I think as well, many people don't necessarily know how to do this. I've often got questions about people interested in doing this, but not sure where to begin. And so I pointed them to that older presentation, but I think it is a really good topic to revisit.
Yeah, agreed. It's crazy to think that 2016 was half a decade ago, and in computer years, that's like forever.
It is, yeah.
The question here, what happens if the array doesn't contain a multiple of 4 elements? Is it a buffer overflow?
Look, that's an excellent question. So this is demo code, and it doesn't handle things like that. Now, I happened to define the array so that it had a multiple of 4 elements in it, which was a little hand wavy there. The way you would actually write this is to check the size of the array and then go through and vectorize as much of it as you can. But if you have like a snippet left over of, let's say, 3 elements at the end, then you would just run normal code on those 3 elements. So you would need a bit of extra code there just to check the length and to handle that.
That's always the tricky thing with demos is not making it too complicated, but not. So Roll saying would be interested to see the C++ performance of the straightforward translation 2 without using the SSE2.
I can directly answer that. It's actually very close to the same, probably is the same. I haven't looked at the generated code. The reason is that our C++ compiler for Win64 uses SSE2. And the library that I was using, I set the macro to use SSE2, and the Clang compiler is very good at optimization, and it probably produces very similar, if not the same machine code for both. What I really want to do is to use a couple of the headers that we mistakenly don't ship in 11.0, but that, as I mentioned, I've put an internal bug report in so that we will ship them in a future release that will allow us to use things like AVX and AVX2, because those are instruction sets that we don't currently target by default, and I would be very interested in seeing the performance there. I would expect that instead of 8 times faster than Delphi, you could double that again, for example, probably.
Do reference counted parameters strings work auto-magically?
Yes, they do. So C++ Builder has full understanding of all the core Delphi types, things like, well, strings, of course, Delphi interfaces, ref counted interface, and some of the special Delphi types, things like currency or tdate time and that kind of thing. So all of those are ones that you can use in your C++ code.
So you do need both. You need Rad Studio if you want to have both Delphi and C++ Builder. I mean, I guess you could buy them individually, but I don't know if you. I don't know. You need Rad Studio, yes.
It's more expensive to buy them individually. Rad Studio is Delphi and C++. That's effectively what the product Rad Studio is. Pardon me. I'm sorry. So yes, yeah. To use C++, you need to have C++ available, and that's a Rad Studio license.
So you commented that Rad Studio can translate Delphi code to C++ automatically. Can you elaborate on that?
Sure. Well, the Delphi compiler does that actually, and you don't need C++ Builder to see that. If you have like a Delphi component, for example, you can go into the Delphi compiler settings, and there are settings there for generating C++. I call them translations here, but there's a setting where it will generate the header file, which is the API translation, but it also generates the object files that C++ needs to link against, and so forth.
So it doesn't generate all the implementation code, just the headers and the object files.
Depends what you mean by implementation code. I mean, it provides everything that you need that you can link into your C++ app to run the Delphi code. So I mean, a Delphi unit will be translated both with the header and with the compiled code. So the compiled code can, the Delphi compiled code can become part of your C++ app. Pardon me. I didn't actually show you that side in this talk. I was focusing on adding C++ to Delphi, but it's very easy, and in fact, I think slightly easier to add Delphi to a C++ app. In fact, that's how C++ Builder works. Every time you use a T button, that's actually written in Delphi.
So this is an interesting question. Can we do the same with Dev C++, or I guess other C++ compilers, or is this a unique to C++ Builder?
No, this is unique to C++ Builder because we have built in the compiler magic to be aware of the various Delphi types and the Delphi ABI. So you remember I spoke about the API and the ABI earlier. C++ Builder is aware of things like the Delphi class layout, and it can inherit from a Delphi class. A Delphi class, a Delphi object has a bunch of extra stuff in it that a normal C++ class doesn't. C++ Builder is aware of that, and so it can inherit from a Delphi class, and we call it a Delphi style class when it's in C++. You can't do that from standard C++ compilers.
So the BPL that you used, is that standalone, or does it require the VCL, RTL, and other BPLs to be deployed with your application too?
That particular one was standalone. I mean, it just uses the Windows message box function. Doesn't actually use any VCL in it. But of course, if you want to, you can have VCL or FireMonkey code written in C++ if that's what you want to do.
I know we Delphi developers like to have our single exe with no dependencies, but frankly, BPLs is pretty cool. Runtime BPLs is pretty cool. I've used them a few times and they're very, very useful. Rolf's asking, can I mix DLLs from Visual C or other C++s in a similar way? So not the same way, but is there some way they can use them from other C++ compilers?
Not easily. I mean, this gets back to the ABI issue. So the underlying, like under the hood, how something is implemented to be compatible. And every C++ compiler implements a different ABI. So our ABI is obviously Delphi compatible, which is different to the Visual C++ ABI, which is different to what you'll get with GCC, and so forth. So when you have anything that depends on the ABI, such as calling method on a class, they are not compatible. What is compatible is what we call plain old C, which is where you flatten everything to a C API. It's not object oriented. It doesn't use any of the things like classes or other sort of complex data types like that. It's just plain old C methods and structs. Because you can decompose and write a wrapper doing that, and then sort of wrap that back into something object-oriented if you really want to do that to access a DLL written in some other C++ compiler. Personally, I think it's a lot easier just to build it in C++ Builder. Actually, there's a question here that I saw, which is, did I misunderstand, but didn't use step by 4 in C++, but step by 1 in Delphi? And yes, that's true. That's deliberate. Because in Delphi, we're just looping through the array and doing math on every element. In C++, we were vectorizing it, where vectorization means to do multiple things at once, basically, using instruction sets that can do multiple things at once. So the code we wrote operated on 4 elements of the array at a time, and that's why we stepped by 4 through the array.
There is a few more questions here. There's one here about the Parnassus components, which you're involved in as well. I know you're very, very busy working on that in Delphi, but I don't know if you want to comment on that being available for 11.
Yeah, that is coming. And apologies for the time that's taking. We do get a few questions about that. It's a little complicated why it was all to do with our build system, and we're just reworking how they're built and how they're integrated. We should get those soon.
Yeah, there are a lot of changes with high DPI in Delphi 11. So David I saying, I seem to remember in the way past there were issues in building C++ based components and using them in Delphi. Is it easy to mix components built with Delphi and C++ in either language apps, VCL and FireMonkey, besides the obvious compiler support for different platforms?
It depends what the problems were. I'm not aware of any problems anymore, because there were 2 sets of problems that we had. Now, one was an ABI issue. I mentioned ABI a lot in this talk. But we actually had some bugs in our ABI between Delphi and C++. And that famously resulted in one particular type, like a T-rect, I think, that sometimes had invalid data when you tried to access it. And that's been resolved ages ago. That's fixed. So the ABI is compatible. The other one was to do with Delphi style RTTI, which is generated. And in 11.0, in fact, we have revised that so that we get full Delphi style RTTI generated from the Delphi style classes. And we get C++ style RTTI generated for the Delphi style types as well. So I haven't really advertised this very much, but we did a lot of, I guess you'd call it quality work to make sure that everything is very smoothly integrated. Actually over the past few years, but like in this past release 11.0, there's a lot of stuff done under the hood to really improve that.
Yeah, David pointed out that the C++ builder compiler includes its Delphi compiler support, so you can build Delphi components, etc. Yeah, it's interesting because if you can build a C++, if you have C++ builder, correct me if I'm wrong, you can create a C++ project and then include a Pascal file that is Delphi code that you can then compile with the C++ compiler. Is that right?
Sort of. So if you have a C++ project, you can add a Pascal file. When you build your C++ project, the Delphi compiler will be invoked on that Pascal file first before any C++ files are built. And part of doing that will be to generate the header, the C++ header translation of that. And that means that your C++ code that wants to integrate Delphi can then just include that header. This is something that I didn't show in the talk because I talked about adding C++ to Delphi, not really adding Delphi to C++. But actually the GitHub link has the same GitHub link that's on screen has a demo showing this in action.
Do you have a list of favorite C++ libraries or code that would be useful or required for a Delphi developer, right? Maybe to use?
Well, that's a good question. The closest we have is that I do have an internal list of C++ libraries that we're adding to get it. And we've built that list because they're really useful libraries. So the one that I demonstrated today is one of them because it's really good for math optimization, and there are a whole bunch of others. And C++ has so many, and many of them are very easy to use with C++ Builder. You can just download them and compile them. And the C++ open source world is vast. So I have a big spreadsheet internally of the ones we're trying to add to get it step by step. And it has graphics libraries and math libraries and algebra libraries and scientific libraries and data format libraries and all sorts of things. So that's a very non-specific answer. Sorry. I'd want to pull up that spreadsheet really to give you an answer. The best I can say is there's a lot out there.
So, and a lot of those are showing up in Get It, right? So that's a good place to people to look for those sort of things.
Yes, in fact, we have something like another 6 or 8 that are queued up to be able to get it sometime soon. But you don't have to use the ones in Get It. I mean, there are many libraries out there, and for many of them, since we support C++ 17 on Windows, and we work a lot on being compatible with other compilers in terms of what our RTL provides and that kind of thing, is usually pretty straightforward just to download and use one.
If an exception is thrown in C++ code, can it be caught in the calling Delphi code?
If it's a Delphi style exception, yes. Generally, it's good, rule of thumb, not to let exceptions pass module boundaries. So in general, you shouldn't, I mean, in any language, really, you shouldn't have a DLL that lets an exception get out. Now, of course, part of the ABI stuff is what happens with things like exception handling. So we actually have done, again, a lot of work under the hood with exception handling, and that is compatible, yes. If you have a C++ style exception that gets out, then that will be exposed a little differently to Delphi, but short answer is yes.
So we do have another session starting here in a minute. I will, I can start it actually, so we can run over. So,
sure.
Question here. You use system : Unicode string in C++ file instead of just Unicode string. Is this to define using C++ system Unicode string instead of a Delphi Unicode string because you're working in Delphi?
No, they're the same, well, effectively the same thing. So Delphi's string is Unicode string. Now we translate that in C++ in the system namespace. So that's why it's system : Unicode string, because it's the system namespace contains our Unicode string. Now we actually have a special header for each string type. The Unicode string is defined in ustring.h. If you have a copy of C++ Builder open, you can go have a look at that. And that's a direct translation of the Delphi type. So it is effectively the same thing. I mean, you pass a Delphi string in on the Delphi side, and on the C++ side, it's defined as a system Unicode string. And the other way as well, by the way, if you end up passing that, you can have a Unicode string in C++ and pass that. Have a Delphi method and call that, and on the Delphi side, it'll just be a string.
If a class is created in C++, does it need to be freed in C++?
That's an excellent question. That's about memory managers. Normally you should always free where you create. Often just in code style, that's good. But when you have different modules like this, you have a package and an exe, then in many languages or setups, the exe might be able to handle your pointer to something and call a method, but it won't know how to free it. Now we have a shared memory manager that but both the exe and the package are linked against. It's our common RCL. And that means that something that's created in one can be freed in the other because it's the same memory manager that looks after the allocation and deallocation of memory. You need to be sure, of course, when you do that, that you are using the common shared memory manager, but that's how it is set up.
Yeah, I remember. Well, I guess I was doing Delphi that way, but yeah. Is Delphi or is C++ as good at stopping memory links as Delphi is?
Sorry, memory leaks.
Memory leaks, yes.
Yes, I mean, like canonically with Delphi, you will have a create, try, and finally free pattern with Delphi. Or for something like components, you'll have the ownership model where your component owns another and then it's responsible for freeing. C++'s pattern, I mean, you can write any C++ code you want, but in C++ you would normally use a smart pointer. I recommend looking into one called unique pointer, unique underscore PTR, unique pointer. And that takes ownership of something. And then when it goes out of scope, it will free whatever it is that it owns. So in many ways, I think C++, modern C++, is better than Delphi at preventing memory leaks. Old style C++ was a lot worse, but modern C++ with the use of those smart pointers, I think is very memory safe. Old style C++ used the new and delete keywords to create and free. And there's sort of a saying that with modern C++, you should not use those keywords in your delete. That seeing them is a bit of a code smell, because the canonical way to do things in C++ now is with smart pointers.
Not knowing C++, is it worth learning C++ or just use Delphi and the C++ available libraries?
Honestly, I think that's a matter of interest. I mean, I quite like C++, although it's a monster of a language. It's very big and very complicated, and I do not understand all of it. I don't think there's anyone who understands all of it. Maybe a few people on the C++ standards committee, but it's a complex language. I think in general it's worthwhile learning other languages just for, I mean, languages express things differently, and through that they allow you to think differently and tackle problems differently, and I think that's good as any programmer. You don't have to learn C++. You might want to use Python. You can use Python with Delphi as well. Ruby, I don't know, whatever interests you.
Yeah, people, I'm sure you get the same thing, but I get people oftentimes that are like, expect me to be like coming down, oh, C# or Java is terrible or whatever. It's like, you know what? I think that a actual senior developer, a modern developer, is going to have multiple tools in their tool belt, and they're going to know other languages, and they're going to pick Delphi or C++ Builder because they know all the other ones, and they know that that's the best one for this job. And sometimes they'll mix things together like you're talking about there as well. So it is good to learn other languages because sometimes it will influence the way you write code in your preferred language, or you'll find ways to extend it with and stuff. So yeah, absolutely agree with you. I just realized I have this exercise strap over my shoulders and it's green, and so it's translucent with the background.
Oh, really? I actually didn't notice that.
Yeah, so it's disappearing like almost completely here. This was from my physical therapy. It's one of those stretchy bands. I forgot I had it on my shoulders. I try to do some I'm sitting on an exercise ball and trying to do the things to keep, a little movement going here while I'm working.
Yeah, I had just thought it was a blue, like strap or braces or something. Yeah, I didn't realize it was transparent to the background. That's rather cool.
I have a tie-dye shirt like David Eyes, and it has a green band in it that does the same thing. Will we be able to use GPU acceleration in applications like this? Besides, are there any studies for GPU accelerated algorithms in RAD Studio?
Look, I mean, if there's a C++ library that implements GPU acceleration, then you should be able to use it. I haven't used any myself. I mean, we haven't put any of those in Get yet. But you know, C++ Builder can compile C++ code, so if there's one out there, use it.
Yeah, it's kind of like the so there you can, like you're saying, but it's like the shaders, right? The shader code that's in FireMonkey, for example, isn't compiled the same way that Delphi code is, but it's injected into the GPU to run there. So it's a weird thing. But yeah, if you have a like you said, if you have a library that uses it, GPU accelerated code, then you could certainly use that. And there are Delphi ones as well as C++ ones. It's one of those things I remember being like, oh, that's not possible. And then I saw some examples, some Delphi examples doing it. I'm like, oh, it is possible. It's a big thing to wrap your head around, but then once you start doing it, I think it's not as daunting as it appears to be. Does RAD Studio, like the IDE or the compilers or whatever, use this technique of mixing Delphi and C++ together?
Most of RAD Studio is written in Delphi, but there are small bits of C++. To actually answer that question, I need to go and have a look at them to see what technique they use. It's possible they use a different technique. So I can't directly answer because I have to go and find out. Certainly the first part of translating Delphi to C++ to create a C++ header and the object files and so forth is used very widely because that's how C++ Builder works. That's how you can use the components and buttons and so forth, because those are all, of course, written in Delphi. And when you have a C++ app that uses them, it's using the Delphi implementation that's just translated so that C++ Builder thinks it's C++.
So the next session is running. People are already over there watching it. I hate having them overlap, but at the same time, I hate leaving questions hanging if you're like really into this. So, yeah, just so everybody knows that. I mean, you already missed 9 minutes of it. If you were planning to do that, so you might have to catch the replay. Are there free libraries for Modbus or Profbus in C++ that can be consumed in Delphi?
I'm not sure what Profibus or Modbus are. I'd have to Google for that.
So I know that it says CAN bus as well. I know that there are Delphi libraries for those. I know Midtoff Software has some, both free and commercial. Well, they're free for personal use. They're used in industrial automation. Modbus is the way you talk to the controller devices in industrial automation settings. Which I assume the other ones are. CAN buses as well. So yeah. And so I'm sure there are C++ ones too. Sorry,
given we're going
cut you
over
off.
time. Oh no, sorry. I was just thinking, given we're going over time, I might just scroll through the questions very quickly. There are a lot here. Just see if there's anything that we missed, because I think you've covered most of them, Jim, if not all of them.
I try to group them together, ones that are overlapping, because I realize we can't always address all of them, but yeah. So, and a lot of great comments too. A few people have shared links or comments on things. Oh, does finally support Delphi's class variables and instance of functionality?
I'll have to check that to look it up. I mean, we support class methods. I need to double check on variables. We translate, I know, 99% of Delphi syntax to C++, but I'm afraid I need to look that up to give you an answer. Let's see. There's a question here as well. For the abstract class unit, is the exe using the unit from inside the BPL? Wondering specifically in the context of the function that returns the C++ version of the class, would it not be in two separate files in a real-world application? Yes, and it actually is in two separate files. So the function that returns the C++ version of the class was declared in Delphi, but it had no implementation in Delphi. It used the external keyword to say, load this method. This method exists, but load it from the package via the external keyword. And then in the C++ package, the method was declared and implemented in C++ with a decal spec, which is a kind of tag of information for the compiler, saying to export it, that is, make it available to be loaded. And so that means the Delphi code sees that a method should exist and knows it should load it from the package, and the package contains the implementation, has it there ready to be loaded. And they sync up that way.
I'm trying to type some of these. I missed what you said there, but I assumed that people. I'm trying to do 3 things at once as well. So,
So question as well. Sorry, Jim, do you mind if I answer?
Go ahead. Go ahead.
There's one here, the translation of the Delphi abstract class. Was that done by hand or via a utility? No, definitely not by hand. If you have to do it by hand, that's so much work and probably get something wrong. No, the utility is the Delphi compiler itself. You can pass flags -j HP something. I forget exactly. I have to look it up. Or of course in the Delphi compiler settings in your project, and it will translate the header and cause the Delphi compiler to emit the C++ object files and static library and so forth. Whatever it is that you need. So short answer is done by utility, and that utility is the Delphi compiler itself. Let's see. I think that's about it. Yeah, the
I will share the question log with you later. So
sure.
Oh, go ahead. Sorry.
I was just saying the question log hasn't had any new questions for 3 minutes now. So I think we're probably almost there. If you do have any further questions, maybe you can write them in now and we'll answer. And of course, my email's on the screen as well. Please feel free to contact about anything. It doesn't have to be about this topic.
Oh, OpenCL. I think isn't OpenCL. I feel like I saw something about OpenCL recently. I'm thinking OpenCV. OpenCL. Is there OpenCL support for C++ Builder?
I don't think we've tested it. I know it's a fairly complex library, and I'm sure with something like that you should be able to compile it. Although there might be tweaks you have to make with something that big and complex. We haven't tried it ourselves, but if you want to use it, I think C++ Builder should be able to handle it. You do tend to find that with some of those very big, very complex libraries, sometimes, you can have hundreds of thousands of lines of code, and sometimes in there'll be something that you need to tweak or change or modify. I've actually done talks on that as well, on how to use a random C++ library with C++ Builder. In general, because every compiler and every every C++ compiler and every C++ platform has these things that are very slightly different to each other, even though the language is standardized. There are often things that are different. For example, Visual C++ has a few extensions and real RTL methods that others don't, and so forth. And we put a lot of work into being compatible with everything, actually. Occasionally we find something where we're not, and then we go and implement that. And it's usually pretty straightforward to work around. For something the size of OpenCL, just because of its size and complexity, I would expect that you'll have to run into something, but it should be straightforward to fix and to use.
All right, well, let's go ahead and go. Thank you so much, David, for this, for all you do behind the scenes and to make C++ Builder and Delphi Ride Studio the great, fantastic tools that they are.
You're welcome. Well, thanks very much. And I really hope this is useful and interesting to everyone watching. And I hope that you'll be able to leverage it and add some C++ to your Delphi app for some useful situation that suits your software.
Awesome. Yeah, thank you. Okay.
All right.
Take care.
Well, thanks, Jim. Thanks, everyone, for watching. Have a good day.
Thanks. Bye.
Welcome to our second video, where we continue to talk about Twine Compile and what it can do for your projects. Let's go back to that large project that we were using in the first video. I've made some tweaks to this project so that it'll take a bit longer to compile, which allows us to demonstrate some of the additional features of Twine Compile. I've also turned on some warnings and errors and things like that so we can see how Twine Compile handles those as well. Let's start by taking a look at probably one of the most useful features in Twine Compile. If we start the build process like we did in the previous video, it's going to start and it's going to start compiling all those files, but slower this time. And we can take this dialog, we can drag it to the side. And because Twine Compile always compiles projects in the background, we can continue to work on that project, editing any of the code files, making any changes, tweaks, adjustments, while the compile is happening in the background, without the compile interfering with what we're doing. For example, I can edit this file with the CPP, I can remove the comment I've just put in. The compile is happening in the background, I get to see the progress, but it doesn't interfere with my working on the code base. That's all very well and good. But the dialog box is kind of annoying because it's sitting on top of everything and I want to look at things. So the next thing we want to talk about with Twine Compile is the fact that all of the dialogs are showing compile information, whether it's the compile progress or, as you'll soon see, the compile error and warning dialog, are always dockable windows. And you can use RAD Studio's built-in dockable window support to create an environment which puts your compiler information, messages, status, output in whatever configuration suits you. Let's go ahead and dock these windows and see what that looks like. My preferred way is to dock these windows at the bottom of the screen in the same pane which RAD Studio uses for the messages window. So let's open the messages window up and it'll appear on the bottom of the screen. Now we'll take a compile window and we'll drag it down into the messaging area and let's put it on the left. Let's take the compile message window, which we can see contains a whole bunch of warnings, and let's put it in the right-hand side. Now we have at the bottom of our screen, we have a compiler status on the left and our compiler messages on the right. And if we go ahead and build the project again, we will see that the dockable windows give us our status without interfering with our ability to write code. You can preserve the location and position of these windows by saving your layout as either a custom layout or the default layout for the IDE desktop. For example, if I go here, save desktop, and I choose default layout and save it, it will ask me if I want to use the default layout and replace it. I say yes. And at this point, whenever I start the IDE, the Twine compile windows are going to stay there and show up in the positions where I like to see them. And this allows you to preserve your favorite coding environment and come back to it whenever you use the IDE. And the fact that their background compiling is available and automatic in Twine compile means that those compile processes won't interfere with what you're doing, and you can continue to work while seeing the status and the warnings show up in the screens. You'll notice that the compile message window is slightly different to the RAD Studio compile message window. It's got some additional features, and let's go ahead and let's actually make an error happen in this code file. Let's make change to the code. I'm going to change that. This is going to cause one warning and one error to appear when I build this specific file. So the first thing you can see is obviously the error shows up. A nice error message that we all expect coming straight from the compiler, and then we've got the warning just below. As with the regular IDE message window, if you double click on the error, it automatically takes you to the location in the code where that error or warning appeared. You can use these toggles at the top of the compiler message window to turn on and off any of the messages that you don't want to see. For example, if I turn off errors, I will only see warnings in my compile messages. Alternatively, I can turn off warnings, and this will only show me the warning messages. This is not a permanent change and only affects the errors and warnings that are displayed for the particular compile. The compiler will still stop when it finds those errors. It will still find all the warnings, but you won't see them show up in the compile message window, and this can be used to reduce the clutter that you see in the compile messages. These are some of the Twine compile features that are available out of the box to improve your productivity. Twine compile is more than just faster compiles. It's a suite of utilities and a whole working environment designed to make your development in C++ Builder as productive as possible.
Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
Let's continue now with rapid application development using Embarcadero C++ Builder and Microsoft Visual C++. We learned in the last video segment that not all object files are created equal. Just because a file has a .obj file extension does not mean that it is compatible with all tools that consume or utilize .obj files. Visual C++ uses and consumes COFF format object files, while C++ Builder tools use OMF format object files. Library files, or .lib files, are collections of object files, so the rules apply to them equally. What we need to do is, rather than statically linking an object file or a library, we need to utilize a dynamic link library, or DLL. That's what this video segment is going to demonstrate. So we're going to create a DLL using Visual Studio. So new project, Visual C++, Win32 project. And let me see here, I'll put it in the root directory and call it VC test. We need to tell it that it's a DLL and that we want to export symbols. Precompiled header is fine. Okay, so it created an exported variable, an exported function, and then a C++ constructor, in case we need one. And it's a .cpp file, so it's C++. We'll go ahead and build this. Succeeded. So if we look at our output files, so kind of have our mixed source now. We have the original C project, now C++ project, solution file, header file. So it created this vctest.h, which has the function prototype for the function we can call, as well as a global variable, and did the special decal spec for the DLL export magic. And then in the debug directory, that's your output directory. By default, for debug builds, we have our DLL, and we have an import library. Now this import library is going to be in COFF format, which we can't use with C++ Builder, as I previously demonstrated. So we'll need to convert that to OMF format using the COFF to OMF utility, debug vctest.lib, and then we say vctest omf.lib. Okay, so I'm going to add the import library that we converted to OMF. I want a library file. There we go. vctest omf.lib. Okay. So now, we're going to try relinking this thing. So let's tell us we have an unresolved symbol. When it linked, it didn't find this function. So I'm going to use tlib to look at this library and see if I can see what the issue is. So I want to do tlib/l. Oh, everything is name mangled. So that's why it's not working. It's building as a C++ module, which we knew, and in C++, you need to be able to encode classes and object hierarchy, not just symbol names. So that's why you end up with all this extra noise around function names. So the solution there is back in our Visual Studio project, actually in the header file for this. Actually, what we want to do is export it as a C symbol. Extern C, like that. And that will disable the name mangling. Now, if you're going to use this in another C project, then you'd want to wrap this if def underscore C++. So we'll build it again. We will create the library again using implib. We'll look at it with tlib/l. Oh, there we go. Now we have a regular looking function name. There's none of this special garbage around it that C++ would put on there. Now, if you're going to have a group of functions that you want to declare in this manner, this extern C, you can use a curly brace and then have an end curly brace. And of course, if you are going to build this for non-C++, so just regular C, you would want to wrap it like that. And that'll also work. So now you can have multiple function or symbols, variables, whatever, defined here, and they won't be name mangled. Let's try building. And it was successful this time. There you go. Now if we run the application, it can't find our DLL. So that's fine. Maybe we can change the debug startup directory so it can find the DLL. Debugger working directory. So I'm just going to force this to the VC test debug directory so that the DLL is in the current directory when it runs, and it should be able to find it then. Voila! And look, it has the number 42. So it successfully called into that visual C++ demonstration DLL, called that function, got the value back with 42, assigned it to this label's caption. This is probably the most basic example, but we have a Visual Studio generated DLL in C++. We exported some symbols as straight C symbols, so a function and a variable, which we're not actually using the variable here. And then we called that exported C function in the form show handler for this default form. I'll go back to that code so we can see it here in unit1.cpp. Now in a real project, you would rename these units to be more meaningful. And I actually haven't even saved this project yet, so I can kind of do this renaming before I save things and give them better names. But anyhow, in this main form, this is probably what I would call this object, this unit. So this class would become tMainForm. The file name would be mainform.cpp. Anyhow, it's going to call that function, assign the result via ANSI string conversion. So this will take that numeric return value and turn it into a string with ASCII or Unicode characters, whatever is appropriate, and place it into this caption property of the label so that the user can see it. While implib is the preferred utility for creating an import library from a Microsoft Visual C++ DLL, you also have the option of using the Embarcadero COF to OMF utility to convert an import library that was created by Visual C++ and converting that to a Embarcadero compatible OMF import library. So the usage of this tool here, COF to OMF, your options, your input file, and then your output file. In this case, the input file is going to be a import library that was created by Visual Studio, Visual C++. That's a .lib file. And the output file is going to be your OMF import library file name, also ending in .lib. In this case, I'm using this vctest_omf.lib. Now, if I just run this as is without any options, it's quite quiet. We can add the /v option to kind of output the symbols, the names, the function names. We see the function names in our that variable name. And it seems to be stripping off the _f and the _n. So that looks a little bit suspect, but let's try relinking this and running it and see what happens. Actually, it fails to link. And that's not too surprising because we saw that mismatch in the names there. So again, if we look at the options here, we have these -lib : 2-character options. And they have first one has to do with C++ name mangling. We're not really concerned about C++ symbols here. Normalizing names instead of aliasing them for standard calls. So this one, this don't perform MSCDecl aliasing. So default is to alias. So we disable that aliasing. So that's that option there. Now it says the imported name is blank, but the internal name is, I guess, the same or unmodified. Now if we relink, link's fine, and it runs fine. So you do have the option of going from a Microsoft-created import library to a Borland Embarcadero compatible import library using the conf to OMF utility. The implib utility goes directly from DLL to OMF compatible import library, so it kind of skips a step or skips a file, an intermediary file. Both options are valid and work. There are some different command line options available with the different tools that might be helpful. In this segment, I'd like to dive deeper into the function calling conventions and the compatibility issues that may arise between Microsoft Visual C++ and Embarcadero C++ Builder. On the screen here, I have a comparison between the two primary calling conventions that we'll be discussing. This is documentation from Microsoft. So we have the CDecl calling convention. This is the default calling convention used by Visual C++. It also happens to be the default convention used by C++ Builder, although that's configurable in both tool chains, what the default calling convention actually is. And then there's also a keyword that can be used to decorate function prototypes to override the default. So for the case of CDecl, it's __CDecl, and then for standard call, we also have the __ standard call keyword that we can use, or you can, like I said, use a project setting or even command line options to override this on a file-by-file basis or a complete project globally. If we read the Microsoft description here, CDecl is the default, that's important. It can do variable argument functions, okay, good to know. Creates larger executables than standard call and explains why. And then over here on standard call, so when calling Win32 API functions, standard call is used. So these are the Microsoft APIs provided with the operating system. That's kind of not important to us since we're not generating Microsoft Win32 DLLs. It's not that critical. But in our case, you know, we don't know. The DLL that you may be dealing with may have been created using standard call, so we'll need to determine that. And explains that variable argument functions are not supported when using standard call. So if you have any function with variable arguments, then you must use CDecl. And going down into the detail differences here, this kind of helps explain things. So we have the argument passing order is the same. It's right to left. We have a little bit difference in the stack maintenance responsibility, whether the caller or the callee cleans up the stack. And then we have a bit of a difference in the name decoration. So these are the exported symbol names, functions, and variables that are exported, and how they are modified or decorated in the actual DLL or import library created by the tool. So even though Microsoft here says that the underscore prefix is used for CDecl functions, except when CDecl functions that you see C linkage are exported, it has that exception there. If we look further under decorated names, it kind of goes into more detail. And here it says the calling convention CDecl, there's always a leading underscore. So there's no exception here about when C linkage is used. And since we are providing a C API, we are using extern C linkage. Also important to note, when you're dealing with 64-bit, your executables and libraries, functions are not decorated, so it doesn't apply in that case. But since we're focusing on 32-bit in this video series, we do have these issues that we need to deal with. Under standard call, you have the underscore prefix, and then you also have an @ and then a number, which is like a suffix after the name. And that indicates the number of bytes that are pushed on the stack and need to be cleaned up following the function call. So they do look a little bit different. The big giveaway is this @ number portion here. If we see that, then we know it's standard call. So if you're given a DLL that you need to investigate, in this case I used the Microsoft tool dump bin /exports and running it on a DLL, and it'll tell me the name of the symbols that that have been exported. And in this case, we have this underscore hello world. It's actually a little bit more useful to look at the import library that's generated by Visual C++, and that gives you the name more clearly, underscore hello world here. And we have no @ sign, we have no number following the symbol name, so we know this is using cdecal. Of course, we have the source code. We can verify in the source code of the project that it did not include a decoration here, that cdecal or center call keyword. In this case, the DLL macro is being defined to nothing, so there's no additional code here. But we don't know, just by looking at the DLL or the source code, what compiler options were used. So it's possible that if it was built using command line tools, that the default calling convention could have been overridden. Or in the project file, if it's using a Visual Studio project file. I'll show you where to find that setting here. It's under C++ compiler, advanced options, calling convention, and it shows you the command line option you can use to override that. But the default here is cdecal, and you have options to override that. So in C++ Builder, you also have a project setting to globally set the calling convention. That is under here under C++ compiler, general compilation calling convention. The default is C, which corresponds to that cdecal calling convention that we've chosen. The default here is cdecal, and you have options to override that. So for this experiment, let's go ahead and do that. We're going to rebuild this DLL, and then we'll look at it again using one of these tools. So it also rebuilt the import library, this .lib file. So now when we look at it, the symbol has the suffix, the @ and then the 0. The 0 corresponds to this void here parameter passing specification saying that there's no arguments to this function, so 0 bytes on the stack need to be cleaned up. If we change this function, say, to accept an integer, let's do this as an experiment. Rebuild and then look at it. I would expect a 32-bit integer, 4 bytes. That should be @ 4 now. There we go. So now we've changed our function name to hello world @ 4. So I'm going to go ahead and go back to the default here, cdecal, rebuild this, confirm. Okay, our symbols. And you can use the Embarcadero tools as well, like tdump, for example. This will confirm that the symbol name here is underscore hello world without the suffix. That's using tdump-c for a cough file because we're looking at the Microsoft-generated import library, this .lib file here. Now, in using this file in our project, I've created a simple C++ Builder application that's just going to call this hello world function. So it's including the header file for the DLL, which defines that function. And it's going to call that function and assign the value to an edit control here. So that's all that line does. Edit one text equals hello world. Now, as before, you need to have the import library in your project. If you don't have the import library in your project and you attempt to build and run, it's going to fail to link because it can't find that symbol hello world. No matching function for call to hello world. So we're going to add that import library. Oh, I'm missing a step. I cannot add the Visual C generated import library. I have to convert that using implib. This is the Embarcadero tool to generate a OMF import library, which is compatible with C++ Builder. And the input is the DLL file. So we're going to say implib and then vctest omf.lib, debug, and then the name of the DLL. Now we can add that file to our project. a build should succeed if the names match. So here's where we're going to identify an issue. It's looking for hello world, yet our symbol is, we've already covered, the symbol is actually underscore hello world. So to do that correctly, when we call implib on that DLL, we actually need to pass an argument to control the output a little bit more. So that's this -a, which adds the underscore alias for MS flavor cdecal functions. So we need to add that argument, -a, and then we'll run that. Ta-da! So something I want to stress is that if the calling convention does not match, if you actually have that mixture of cdecal and standard call, more specifically, if Borland tool thinks that the calling convention in the DLL is standard call, but it's actually cdecal, it'll seem to work. It'll actually work probably 99% of the time. You'll end up with a little bit of stack corruption. A recent quote I read that I liked is that memory corruptions are like ricocheting bullets, and that you don't know what they're going to hit or when they're going to hit or how much damage they're going to cause, but much of the time they don't cause any damage. An anecdotal story, I had a project that's was a mixed project like this using Visual C++ and CBuilder. And for about 20 years, it actually had mismatch calling convention between what Visual C++ was generating and what C++ Builder was expecting. And it worked. The code all worked. Occasionally, we'd add a function to like a control handler, like a button click event, and we'd get some weird behavior. You know, get a null pointer, dereference, or invalid instruction, or something like that. It was kind of shrugged off, like, well, that's weird, and then we'd put a deferred call in a timer, in a VCL timer on tick handler for that same operation, and it would seemingly work fine. So it just didn't work in that particular event handler. Didn't know why. It comes down to not having the perfect agreement between the calling convention of the DLL and the application that's using the DLL. So it's very important that these match. Just because your application linked and ran does not mean that you necessarily got it right. So you need to make sure, double check that. Perhaps using some kind of profiling tool or runtime validation would catch that kind of corruption as well. But in this historic example, the code actually ran just fine for many, many, many years. It was only occasionally we had to work around that issue, and the workarounds always seemed to work. So didn't really know the solution until recently.
Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
In this video, I'm going to be demonstrating how to integrate externally built object files with your C++ Builder application. To do this, I'm going to be using the C++ Builder IDE, known as Rad Studio, also some external source modules, like these that I'm using Notepad here to edit, and then I'll be building those from the command line using 3 different C and C++ compilers. If you're coming from a Visual C++, Visual Studio background, and you're more familiar with those key bindings, you might want to enable an option under Tools, Options, under User Interface, Editor Options, Key Mappings. You have a Visual Studio Emulation option. So if you're more familiar with those key bindings for, say, compiling or linking or setting breakpoints, then you might want to use that option. So the sample external code that I'm going to be using is very basic, just this function that returns an integer, and I chose the magic number 42. I have a C++ and a C version. Currently those are exactly the same, and then a header file that declares the function signature. To use this, you first want to create an application. Let's go ahead and create a Windows VCL application. That's your most basic application that's kind of a blank slate and targeting Windows only. And what we're going to do is insert a label. And I'm going to rename it just label. And I want to make it bigger, more legible for the video, so I'm going to change the font size here. I don't want a default caption, so I'm going to delete that. And then I'm going to double-click my form that's going to create an event handler for the form create. So every time that form is created, this code is going to be executed. What we're going to do is set that label's caption to the integer value returned from that C function I showed earlier. Now, although this caption is a Unicode string, a special C++ class, VCL class, has an overloaded assignment operator, so it can convert from integer to text no problem. And when I try to compile this, it's not going to know what return int is, so I'm going to need to include that header file where I declared that function. And it's not going to know how to find this header file unless I tell the project settings that I have another directory where include files can be found. And that's under the C compiler, directories, include, search path. Now, this should compile, but it's not going to link, because it's not going to find this symbol. But let's go ahead and compile it, the traditional IDE Control F9 command that does a make. So here's our linker error, unresolved external. How we add an object, an externally built object, we right-click on our project, say add, tell it we want an object file. And then we'll go ahead and go with the C++ built. So the different compilers used here, this is the going to be the object file built with the traditional or classic Borland C++ compiler. This is the Clang-based compiler. That C there indicates the new Embarcadero Clang-based C compiler, C++ compiler, and then of course we have Microsoft Visual C. So I'll go ahead and choose the traditional. When you create a new project, the default is to use the new Clang compiler. You can change that if you like. If you have a preference for the older compiler, is here. Use classic Borland compiler and it's default to false. So if I enable that, it's going to use that BCC32 compiler. Otherwise, it's going to use BCC32C, BCC32X. Those are both drivers for the underlying Clang compiler. All right, it compiled. We run it, and it got a return value from that function. So that object file, while externally built, is compatible with our C++ builder project, and we got the magic number we were looking for. Now, let's say we try to use the Microsoft built object file instead. This is going to fail, and the reason is indicated down here. This object file is not compatible. It's not in OMF format, which is the format that the Embarcadero tools create and use for 32-bit Windows. It's possibly in COFF format, and it actually is in COFF format. So let's get into the details of these object files and why some would be compatible and some may not. So Embarcadero supplies a tool called tdump, stands for turbo dump, and the basic usage is to supply it a file name, and it will tell you the details of that file name. So we'll go with our traditionally C built C module, and then maybe we can do some side-by-side comparison here. Say the C++ built version of that same thing. And the important thing here is that function symbol we're looking for, return int, we see it's different. We have a leading underscore here in the C version with no leading underscore in the C++ built version. So this is the version that we linked with our application and worked. So let's look at the version that didn't. That was the Microsoft version one. Oh, look, it won't support it. tdump by default assumes that you're passing it an OMF formatted file. So you do have the option of specifying -C for COFF format. That's that Microsoft generated format. And it can display our file here. Oh, look here. Here's our symbol we're looking for, return int, and it has this ya xyz or whatever. This is called name mangling or decorating. This is something that compilers will do to C++ functions. If we look at the C version of this same thing, generated by Microsoft, we don't have the name. So even though it's the same source, compiled just with a different file name, so it triggers the C++ compiler rather than the C compiler, you get a very different symbol. So this name mangling, although right now that is not our primary issue, we will need to address that later, so it is important. But right now, the main issue is that this file is in the wrong format. Embarcadero does supply a tool called COFF to OMF. And the purpose of this tool is to convert import libraries for DLLs. If you pass it an object file, it will pretend to convert it. So let's do that. Let's pass it that C++ MSVC file. And the output file is going to be, we'll call it omf.obj. So it didn't complain. It did create our omf obj file, but if we dump that, it's pretty much blank. If we use like a hex dump on it, yeah, there's really no data in here. There's no code. There's no symbols. It didn't really work. So don't be misled. You cannot really convert a COFF format object file to a OMF format object file directly. Let's say you're using a C++ code base, highly likely, and you want to access a class member. So let's define a basic class and make this a public member of that class and call it static so we don't have to instantiate, and that's all we need. And then in our C++, we're going to say that it's a class member, and we need to include our header file so that we get the class definition. So previously, had very simple names. It was just that return int, like so. But now that we've rebuilt it as a C++ class, we get actually a class name in our exported function name here. To use this in our VCL application, it's compatible. It works. But let's look at what Microsoft did with that symbol name. Microsoft does have an equivalent tool called dump bin. It only supports COF format, but let's go ahead and use that as an example. /symbols, CPP MSVC. And now we see a highly decorated function name here. So this is not going to be directly compatible with C++ Builder, even if we could link it. So the linking issue we'll solve later, but the symbol name issue is still here. Now if I wanted to do this in a FireMonkey application, that's the multiple device framework, it'd be very similar. I'll go ahead and demonstrate that. So I'm going to do a new multi-device application. And again, I'm going to drag a label. The object model is very similar, although not identical. So some steps will be a little bit different. So again, I want to make this large. So that's under text settings, font, size. Set the default, I'll make it big. And we see here that it's kind of being truncated, so we want to set this auto size property to true, so it accommodates the size we want. We don't want a default text. In our name, we want to set to just label. Again, double click to create your form create. Event handler, label text equals basic : return int. Again, we need our header file. We need it included in our project. The directory where our header file is stored. And we need to add the object file that is compatible. Voila. So this is a FireMonkey or multi-device application. You can target lots of platforms, iOS and Android and Mac OS, with the same code base, very similar framework to VCL. Although the symbols are compatible here, and our object file is compatible and we're linking, it is possible that we could have a calling convention mismatch. You can also have linking issues when you change the default calling convention of your built object files. So it's best if you're going to be exporting symbols from a C module to explicitly state the calling convention in the header file. That would be done like so if you're using cdecl or standard call, like so. Now, the issue with object file compatibility also applies to libraries. Libraries are collections or archives of object files. So if you use a tool like the Microsoft lib utility or the Embarcadero tlib utility to combine object files into a library file or a .lib file, you could have the same issues with compatibility. You need OMF format library files to be linked using the Embarcadero tools. Even though the file names have the same extension, .obj or .lib, don't be fooled. You do need to look more closely at these files. And again, the symbols, the calling convention need to be compatible. And the symbols can be affected by C++ name decorating, the calling convention, command line options. All these things can affect the symbol names that are exported by the generated object files and library files. All right, so we have a working application that uses an externally built object file using Borland tools, but we haven't been able to do that with Microsoft tools. The way to do that would be to create either a DLL or a COM object that we could call functions in or access data from. We're going to be demonstrating in the next segment how to create a compatible DLL using Visual C++. Reviewing what we went over in this video, we created applications in C++ Builder which linked with and pulled data from externally built object files. We did this with a VCL application for Win32, as well as a multi-device application using the FireMonkey framework, also for Win32. We demonstrated how object and library files linked with C++ Builder applications must be in OMF format, and how to use tdump to dump the details of object files and library files, both in OMF and COF format. Also, we covered that the COF to OMF utility supplied by Embarcadero cannot be used to convert object and library files from Microsoft COF format to the compatible OMF format. In addition, we detailed what can happen with exported symbol names based on the type of compiler used, or the mode of the compiler, the type of source code, the calling conventions of the functions, whether or not you're exporting a C++ class member versus a global function, and the name mingling methods chosen by the tool vendor. We also alluded to the fact that there is a solution to this object and library format problem, and that is DLLs. We'll be covering that next.
Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
To this point, we've demonstrated how to call into a Visual C++ DLL, capture the return value of a function, and display that value here. That's what this 42 is. That may be a realistic use case in some scenarios, but you probably have more interesting return values or data that you'd like to share between your DLL and your application, or even pass values into the application. So let's create something a little more interesting. Let's try a string. That's probably the next most obvious type. We'll create another function that'll return a constant character pointer, and we'll call it get star. In this case, we're just going to return a string constant. Not going to do any fancy allocations or anything for this test, so should be able to build the DLL. And then, as I demonstrated before, we need to create an import library. We need to update our import library, really. So we're going to overwrite. It's going to overwrite the import library that we have, and it's first we have to give the destination file name .lib, and then there we go. So now when we go over to C++ Builder, now we're going to have, let's say, another control, or we could even use the same label. Instead of calling that function, we'll call the getStir function, and then do a make. Okay, and we'll try running it. So it linked good. That means it found our new getStir symbol from the DLL in our import library. That's good. We run it, and it says hello world. So it passed back our string constant, and we were able to print it just fine. Okay. So now let's try some dynamically allocated memory. To do that, we'll use stirdup. That's the equivalent of calling malloc with the string length of the string you pass it, and then copying it into that string with a null terminator and returning that. So it's kind of doing all those things in one operation, and it's going to return the value. And if you're familiar with stirdup, you know it's like malloc. You know that you should be freeing the memory. I'm not going to do that here. I'm kind of purposely creating a memory leak here. Oh, and we get a warning about it being a deprecated function. That's fine. There's ways to disable that in your Visual C++ build environment, but for now we'll just ignore the warning. Anyhow, you see it works fine. But we know now that there's a memory leak, so if you ran any tools that capture heap leaks or corruption, something like Valgrind would report a memory leak on that stirdup allocated memory. So just for fun, let's see if we can free that memory. So we'll say, we'll go ahead and print it, and then we'll try freeing it. Now, I can tell you this is not going to work, but you might try this, and then I want you to know why it'll fail. The DLL has been compiled and linked with the Microsoft C runtime, so it has its own allocation heap for use for functions like malloc and calloc and stirdup. So when we get that pointer, that's fine. It's pointing to that DLL's heap memory, which we can access just fine for read. But our free call is going to call into the Embarcadero C runtime library, which has a different heap, and it's not going to know what that pointer is. It's not going to be able to free it. So it'll probably throw an exception. Before we can call free, we need standard lib. What is going on? Why is free not defined? No match. That's interesting. So you have to call : free if you want to call a standard C library function. Okay. And then we need a typecast, because this is C++. All right. So it did not throw an exception, but I do know from experience that that memory is not actually freed. So what you would need to do in this case is you would need to create a function in the DLL that will free that resource and call its free implementation. So let's create a kind of equivalent here, or a counterpart to this function. Call it freestir. You pass it the string to be freed. It calls free. And we can't forget the DLL call decoration there for the calling convention consistency. So we also need standard lib here. And we have the same warning about C++ness. And we need to do that same creation of the import library, back to C++ builder. Again, I'm not freeing it, so we know there's a memory leak there. So instead we're going to call that freestir function. Basically like a little wrapper around free. So a problem I'd like to demonstrate now is a situation where the program compiles and links and seemingly runs okay, except, well, I'll demonstrate the issue here. So we run it. So we see this privileged instruction exception. That's actually happening when it's executing this freestir function, which is calling into the DLL. Looking at the DLL, there's really nothing too complicated, it just calls free with a little typecast here. So this is telling us this problem with the calling convention. We are using DLL call here. We don't technically need to do this VC test API macro in the actual implementation, just in the header file. The problem is we have a mismatch here because we're only doing this standard call type when it's a Borland compile, which is the Embarcadero tools. So simply always defining this, otherwise it's going to default to cdecal when compiled with Microsoft Visual C++. Should fix the issue. So we'll rebuild that. We're missing need to use the macro everywhere now. And then build. And then make sure our import library is up to date. And then remake this. Application. And we run it. Now there's no exception. So it successfully allocated the memory in the DLL, returned it, we set it to the caption of this label, and then we freed that memory. And the label is fine. It has its own copy of that memory. It doesn't need to have this pointer be persistent. So it's fine to free it. We just can't free it using the Embarcadero C runtime library. We have to use whatever was in the DLL. So in this case, it's Visual C++. We need to make sure that whatever's allocated by the DLL is freed by the DLL. And the converse is the same as well. So if you allocate memory in the application that's built with C++ Builder, you can't let that memory be freed by the DLL. So let's go ahead and try an instance of that as an example. So we already have a freestir function we can call. So I will just allocate another string and call freestir. So in this case, I'm allocating it in the application and trying to free it in the DLL. And we get a debug assertion with a invalid heap pointer. We're passing a bad pointer to the free function in the DLL. So this exception actually comes from the DLL. If we want to debug this, we can hit retry. It should pop up Visual C++. It kind of popped up a window and then went away. See if we can attach to it using Visual Studio. So I'll say debug, attach to process, project 1. Look at that. By attaching in Visual Studio, I'm able to see where the exception is actually occurring. Now, there's an exception to this rule. Well, not an exception, but a workaround. So if you really want to do that operation where you allocate memory in either the application or the DLL and you want to free it in the other entity, you can use these Win32 API calls, heap alloc and heap free, and attach them to the process heap. This is kind of a global heap for the process that's not attached to the C runtime library. So you can't use stirdup in that case. Yeah, stirdup won't work for the because you need to actually call malloc. These macros are only for malloc and free. Let's see if we can give an example. So we're going to call free on this. Let's go ahead and build this. Can't build while the DLL is running. Try deleting it. Access is denied. Oh, looks like we got a couple ghost processes. There we go. I should delete that. Yeah. Okay. Let's copy those macros to here. Now we're going to do something like malloc 5. So now this example is just going to allocate 5 bytes, copy the string test into it, and then see if we can free that same memory successfully now that we're using that heap-free implementation. Okay, no error. Anyway, so that demonstrates how to allocate memory using the Win32 API functions heap alloc and heap free. You can allocate memory in the application, free it in the DLL, or the opposite if that's your desire. But that does require that you do not call malloc and free, but instead use these Win32 functions from Microsoft. Since we are talking about a C++ project, and the normal ways to allocate and free memory in C++ is the new and delete operators, I wanted to clarify you can't use those either. That's the equivalent of a malloc and a free, and you can't perform, say, a new operation in the application and then a delete operation on that same object in the DLL. That's not going to work. The only allocation and free would be through the Win32 calls, heap alloc and heap free. It might be better to not use macros, but instead create functions. You might want to create the equivalent of, say, calloc, where it zeroes the memory, or maybe your free checks the pointer to see if it's null and performs an assertion, something like that. But these macros do work if you just want to do a global kind of macro replacement on all calls to malloc and free with heap alloc and heap free. So the Microsoft help for those functions. So there's also heap realloc, a realloc equivalent if you wanted to make this more complete. You could have a macro or function for realloc. Or if you wanted to reallocate memory rather than freeing it and allocating a new block, but rather resizing an existing block, you could use a macro, kind of like this pointer. Let's put a breakpoint here. I wonder if I can attach to it with a second debugger. Attach. Nope, can't do it. Okay, so you can't attach if there's already a debugger attached. Fine. So a better way to test this, because I want to be able to step into that code, make sure it's executing as I expect. So instead of executing this code when the form is shown, instead I'm going to create a button and then just perform these operations when the button is clicked. Go to my palettes of components. T button is fine. What we want to do is an on-click event. If you just double-click, you'll get the on-click event. You move the code there. Okay, so what this allows me to do is attach with the Visual Studio debugger and then click this button, which will execute this code, and I'll be able to see it call this freestir function in the DLL. So I'm not using the Rad Studio debugger in this case. I've got my button. I'm not going to click it yet. I'm going to go over to Visual Studio, debug, attach to process. In this case, the program name is called Project 1. I'm going to attach to it. I'll go ahead and put a breakpoint here in this function. Thank you. Now I can click my button. It should hit that breakpoint. There. So I know it called into my freestir. I know it's about to call free, which is actually this macro to heap free. And that was successful. I don't have the symbol. I can't load the symbols of the rest of the project, so it's best just to continue running. And then if I want to do any debugging, I would now want to detach. Okay, so in this case, I'm going to demonstrate how you can debug the same application using both debuggers. So I placed a breakpoint in the button click event for this button. So if I click the button, hit the breakpoint, go into the function, I can step through the code. If I want to debug, say, this freestir function, which is in the Visual C DLL, I would need to detach from the program in CBuilder. The program is still running. Now I can go into Visual Studio, debug, attach to process. Again, it's called Project 1, attach. I have my breakpoint on the free function there. I go here, I click the button, and voila. Now, if I step out of this function, it's going to jump back to the C++ builder code, which I don't have compatible symbols in this debugger, so it's not really going to work. But I can debug this function that I'm in, no problem. See, symbol file not loaded. So it can't continue to debug, but I can definitely switch back and forth by detaching and reattaching.
Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
So far, we've shared integers and strings, single byte character strings, between the DLL and the application and back and forth. You probably will come across a case where you'll want to share more complex data types like structures or unions. I'll dive into that now. You want to, of course, define the structure in a header file that's shared between the application and the DLL. So I'm going to go ahead and use the Visual Studio created DLL header file here to define the structure that we're going to be using. So I'll just call it struct test. The contents of the structure are actually important, and also the order of the elements is potentially important. The types you use and the interpretation of those types. So if you're using like a macro like Word, that's kind of a Windows macro for 16-bit integers, then you want to make sure that's interpreted as a 16-bit integer, both in the application's compiler and in the DLL build environment. If you use a data type perhaps a little less specific, like int, then that could be sensitive to different environments, particularly mixed 32-bit and 64-bit environments, where an integer could be either 32 or 64-bit. So my recommendation would be to use the types for integers from the standard int header file. This is part of C99. And this gives you types with specific bit widths for integers. So you could say like int32_t. It specifies that you mean a 32-bit integer, and that should be universally accepted as such. No compiler, tool chain, and architecture should interpret that as something else. If you want, say, at least 32 bits, I think there's a at least 32-bit int, least 32. There's also a int fast 32, which tells you I want the fastest integer representation that's at least 32 bits. So it's, that's probably not a good one because that could be interpreted differently by different compilers. So you want to probably stick with the specific types. This is a signed 32-bit integer. You would use uint32_t if you want an unsigned 32-bit integer. In this case, I'm just going to go ahead and stick with signed types, just for examples. I'll call this word, and then we'll have like a uint8_t. Let's have like an array. An odd size is good. So this is probably a good example of a simple structure. The padding between, if there is any, the alignment and the required padding between elements in a structure is implementation dependent. So the C standard does not dictate whether or not there is actually space between these elements in the memory and how much space that would be. So kind of the normal default padding would be that you'd want natural alignment. So a 16-bit integer would fall on a memory address that is evenly divisible by 2, whereas a 32-bit integer would be stored in a memory address that's evenly divisible by 4. In this case, if the structure starts, say, at offset 0, so this member would start at offset 4, and then since 4 is evenly divisible by 2, there's no padding required here. This last element, being an array of bytes, only needs to fall on a byte boundary, which is really every address, so that would be fine. The default structure packing can be overridden with command line options to the compiler and also with preprocessor directives. I'll demonstrate those later. For now, we'll just stick with the default packing and see what the difference, if there is any, between Visual Studio and C Builder with regards to their interpretation of the structure definition. So in order to pass this in, we'll pass it by pointer. And then it's a good idea to pass the size of the structure. That's going to allow us to double check that both environments agree on the size of the structure. This is the function definition. And we'll do some checking here. Let's go ahead and make this function return an integer. Give us an idea of success or failure. Kind of the normal C standard is an integer, a function that returns an integer with an error status. 0 indicates no error or success. So I'll go ahead and say if size does not equal size of star test, and we're going to return a non-zero error. Gives us an idea that something bad happened here. Otherwise, we're probably, well, this is probably fine for now. We'll just do a size test. We could also like modify the structure. So let's say if you call this function, we will set all the bytes in the structure to 1. So we'll check to make sure that the size matches Visual C interpretation of that structure, and then we'll set every byte within that structure, the pointer that it's pointing to the value 1. Oh, and I need to redefine that as returning integer in the header file, so they match. And that's why you always want to include your public header file in your C file, just to confirm your function prototypes match. And return 0 on success. I can't write it because the application's still running. The Windows, you can't overwrite DLLs that are executing. Okay, so let me run my implib again. And then let's see, now we want, when we click this button, struct test. So in this case, we don't want to use a pointer here because we're actually instantiating the test object. One shortcut for initializing everything to 0 is that. And then we'll go ahead and call that test function. It's in the C namespace, so : test. And let's capture the result. And then we can put the result in the edit box. Control F9 to compile. I forgot the size argument. So being C++, even though this is an integer and this is a string, it's going to do the magic to convert that integer to a string using decimal representation. So let's run this. Hit test. Oh, look. It says 0. So that's telling us that our test function returned 0, success. We're trusting that the test was actually modified, this test structure was modified. So let's go ahead and put a breakpoint here and click that button again. And then, so if we look at test, so here, you see here, it is successfully set to all zeros. If you didn't initialize it with this, of course you'd have like uninitialized values, possibly like hex CD or some other garbage, some pattern if it's a debug build, but 0 is what we want for our test case here. And we call this function, it should set it all to 1. So I'm going to say step over, and then, oh, there we go. We see now all the fields were set to 1. And apparently they both agree about the contents, or the size, excuse me, of this structure, how many bytes that should be. If we're not sure, we're curious, we could output that to debug output, or we could put the content, the size, into that edit box. So we could even do it in the constructor up here. So the default value of that will be the size of struct test. Let's give us a quick way to check what the actual size of that structure is. Okay, so 12 bytes is what C++ Builder is saying that structure size is. We know now that the Visual C agrees with that interpretation. So 4 plus 2 is 6 plus 5 is 11. So there is some padding in here. Being that this is 12 bytes, that indicates that this value is at offset 0. This value is at offset 4. This should be offset 6. But since it's an odd number, it went ahead and included an extra byte of padding at the end. Because 6 plus 5 is only 11, and it's a 12-byte array. So what I'm what I'm suspecting is if we change this to a 6 and we rerun our code, we don't even need to rebuild the DLL, but we do want to rerun our code. So it's still 12. So the padding in this case is at the end of the structure because it was an odd number of bytes. It adds an extra byte at the end because anything that follows that memory will want to be on an even byte boundary. As another test, let's try just to demonstrate how padding works. We'll put that back to 5. We'll put another integer down here. Unsigned int. Call it u. Rebuild. Oh, I don't think it relinked. Yeah. So it doesn't know. Yeah, we need to do a make. Okay, so now we're 16 bytes. And that's because an integer is 4 bytes. So now that 0 is in between these two. That 0 that it added at the end is actually between these two. Or I should say the 0, the padding. There's 1 byte of padding here. that's being automatically inserted by the compiler. And then this field would be at offset 12. 6 plus 5 is 11 plus 1 byte of padding, 12. And it's a 4 byte integer. Happens to be because 32-bit architecture with a 32-bit integer. So this structure is compatible between the two environments, and that's assured by passing the size. It's not perfect. It's possible that the compiler, like say, one compiler could put padding here, and then another one could put it at the end or between two other fields, and you wouldn't know that just from the size of the structure. It's a good smoke test, but it's not a complete check to make sure that the offset of every element is exactly the same offset between the two compilers. Some elements of structures, like bit fields, are completely implementation dependent. So if you have something like int b:1, you're saying this is 1 bit. How that bit is actually stored, represented in the structure is definitely implementation dependent, and you may see differences between the compilers again. So tread with care. All of these gotchas or caveats also apply to unions. So whether it's a union or a structure or a union of structures or whatever, you're going to have potential issues with structure packing and padding and alignment. So the Visual C command line compiler, so that's CL, compile and link. If you look at the help, I think you'll see options for controlling the packing and padding. There we go. So the Visual C++ / capital Z, lowercase p, and then a number tells the compiler to pack on certain byte boundaries. You can also control this in the project settings somewhere for the compiler. You can also override the default structure packing in Visual C++ using the struct member alignment option if you want to make your structure smaller. But if you do so, then you also have to control how the structure is interpreted in C++ Builder so that they both agree. So let's go ahead and try changing this to make this what you call packed structures by default. So there's really going to be no additional padding added. Now, the advantage of that, of course, is your structures are a little bit smaller. So if you have a lot of them in memory, maybe you want to do that, you're storing them on disk, you're sending them over a communication interface like a network interface, then maybe you do want small structures. Doing it globally like that with compiler option is probably not desired. You might have a lot of structures that would require additional code that the compiler is going to have to insert to deal with unaligned values. So you might end up with bigger, slower code, even though your structures are smaller. So you probably would want to do that on a case-by-case basis and not globally with a compiler option like I showed. And you can do that with pragmas, but I'll demonstrate first here doing it globally. We rebuilt that. We don't actually need to rerun implib because we're not changing any symbols. We'll go ahead and make sure this is current. We run it. So C++ Builder says that our structure is 20 bytes. We click the button, which will then execute our DLL function called test. The result is -1. And that's because of that option we changed where we changed the default structure alignment. By specifying 1 byte alignment, every element is going to exist on the next available byte. Every element in that structure is going to be placed in the next available byte. There's going to be no padding between them. So like I said, you end up with inefficient code, although your data is smaller. And C++ Builder is going to use some kind of structure padding by default so that the code is more efficient in dealing with the structures. So now we have the two environments don't agree. The code did not run correctly. So hence we got this -1 failure when we executed the code, the function. To change that, we could do it globally in C++ Builder. Again, not recommended, but I want to demonstrate that. Data alignment, okay. That's interesting, quad word. Okay, so now that we have a clear structure size mismatch issue between the two entities, the application executable and the Visual C++ library DLL. So I'm going to add a function to get the size of the structure. So we're basically querying the DLL saying, what is your idea of the size of the structure? Okay. Now we've added a function, so we're going to have to recreate our import library. And what I'm going to do here is go ahead and create 2 edit boxes. I can do it with copy paste here. And I'll add a couple labels here. I'll call this BCB, or just CBuilder++. So this is going to be CBuilder's idea of what the size of that structure is. And then another label for the second edit box. Okay. So now we've got edit 1 and edit 2. Back to our code. So edit 1 is definitely going to be that. Edit 2 is going to be get size. And that's running in the constructor. It's maybe not a good idea to do it in the constructor, but we'll go ahead and try that. There we go. So we see the mismatch here. CBuilder gives us a size of 20, and Visual C is saying that the structure is 19 bytes in size. Let's do a little experimentation. See, maybe it's this bit field that's the issue. So I'll take that out and recompile. Oh, are we getting quite, okay, still off by 1 byte. So there are pragmas that you can use to control packing. Microsoft and Embarcadero agree on how to override the structure packing on a case-by-case basis using pragmas. And that syntax is this pragma pack operation. So you call pragma pack push, that takes the current structure packing value, pushes it on a stack. You override it with a number of bytes. So in this case, it's a single byte, meaning no padding. And then after you've defined all your structures in unions with no that you want that overridden packing, then you would do a pack pop to restore the original structure packing value, whatever that was. Previously, I had overridden the global structure packing default. I'm going to change that back to the default. Changing that back to the default, that'll test that the structure packing pragmas are working correctly. And now I should be able to get the same structure value in both cases, in both the DLL and the application. Ta-da! So the pragmas work on overriding the structure size, and both the DLL and CBuilder agree now that that structure should be 15 bytes in size. We run the code, step over, F8, check the value. 0. 0 is success, if you remember. So now the test contains a bunch of 1s rather than the default, which was 0s. There we go, a bunch of 1s. So that's how you handle structure packing, padding, alignment issues, and compatibility between the two environments.
Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
So I created this DLL function in Visual C++ that just writes a string to a file, and every time it's called it'll append another string to the file with a new line separator. And called the function writeString. In our C++ Builder project, I want to call this function upon user input, so I already have this edit box with the text that the user can edit, and then I have a button. So I'll double click that to create a button click event handler. And upon calling that, we're going to call that writeString, which is a C function, so it's in that namespace escape sequence : :. So we're calling writeString, and then we're going to pass it the edit values text. Now this is a Unicode string. It's a multi-byte character set, and we need to convert that to that single byte character typical ASCII C string. So if you just call cster on this, you're going to get a compile error. So we get this error down here about converting a wide char to a const char star. What's that? There's a UTF-8. I want to get a Unicode to UTF-8. So instead, let's create an array. Unicode to UTF-8. So the destination is stir. Source is going to be this guy. The max bytes is going to be the size of stir. Let's try running it with the debugger. There we go. Step over that function. Look at stir. Hey, looks good. So now that should run. Okay, so file does not exist. Click our button. Now it's there. Click the button. It's there. Every time I click that button, it's going to keep adding to the file. So all we're doing is passing that string, and if I change the text to something else, there. So I'm passing the string to the DLL, and it's writing it to the file. This conversion to single byte characters using UTF-8 encoding, you may not need that if your DLL's function accepts multi-byte characters using the same number of characters per, I think wide characters usually 2, so UTF-16 characters, then that would work okay. But this conversion looks like it's necessary for the single byte characters that are expected by traditional C functions. Some details about sharing strings between modules. Traditionally, C strings are null terminated. However, that may not always be the case. Sometimes a length parameter or a length data is also passed around and the string may not be null terminated. Additionally, the size of that null terminator may not always be exactly 8 bits, but typically is the size of the characters used in the string. The character size, or the bit width, of the encoding used by default may be an issue to deal with. The traditional character, or char, usually represents a single ASCII character in 8 bits. However, a character pointer may point to an ASCII or a UTF-8 string. UTF-8 characters are represented by one or more chars or bytes. A wchar_t is implementation defined, but typically 16 bits on Windows and may be up to 32-bit on other platforms. On Windows, it may take multiple wcharts to represent some characters. The size of the Windows.h defined tchar, or _tchar, varies based on the predefinition of the Unicode preprocessor macro. By default, when using the command line compiler, the size of a tchar is 8 bits, but when Unicode is defined, it's 16 bits. In the Visual C++ and C++ Builder IDEs, the project settings default to enabling Unicode support and a wide tchar, so 16 bits. When Unicode support is enabled in both environments, most characters are represented by a 16-bit wchar_t. Also, the wide variant of the Win32 API functions will be used by default, so a message box, for example, will point to a message box W. The default IDE behavior may be overridden via project settings, or command line options. The default behavior of the Visual C++ command line compiler is to use single byte encoding with 8-bit characters, and the A, or ANSI variant of the Win32 API functions by default. So an invocation of message box would actually invoke message box A. When combining modules that are built in different environments, you may have to deal with the differing string types by providing explicit conversion between them. In that example, we're passing a string. In this case, we happen to be converting from multi-byte characters to single byte characters for the format of the string, but we're passing that string to the DLL, and the DLL is writing to a file. The same would work in the inverse if you wanted to, say, query a DLL for a string and then the application writes to a file. No problem. You're just passing really the string back and forth. Let's say you had the file open in the DLL and you wanted to write directly to that file in the application. Could you do that? Let's try that. Let's say we have a function called openFile, and you pass it a file name, and it just returns the result of fopen, which is a standard C function. And we'll go ahead and keep opening it for append. That's fine. So open file, and it's going to be a fname, and then it's going to return a file pointer. We need to include standard IO to get that type. Okay, we got a warning about fopen being unsafe, and then everything succeeded. So now, rather than calling write file, we're going to call that open file. So we call file pointer fp equals : open file. And this standard functions to write to a file are like fprintf. I also have fwrite, fputs, functions like that, but I'll use fprintf. Stir. And then, so write to it, and then we'll close it. Seems like a logical sequence of events. Oh, didn't update my import library. There we go. Okay, and then let's run it. The file name is still going to be output.txt, and it's going to append, but let's go ahead and look at this file first. So it's already got something in there, so let's go ahead and delete that, just so we know we're writing new data. Click that. Oh, and we get an access violation. Let's see if we can find out where this happened. Yeah, so it crashed in the Visual C code. Unless you're really good at reading assembler or machine instructions, machine code, you're not going to probably make a whole lot of sense of that. We could reproduce this crash and then capture it with the Visual Studio debugger, but I actually know exactly what's happening here. A file pointer cannot be passed between a DLL and an application and reused. This pointer is going to point to some memory in the C runtime library, which is linked with the DLL, and this fprintf is part of the C runtime library of the application. And there are two different C runtime libraries, two different instances. They have different ideas of what a file stream looks like, the type, and the memory where they're storing that data is completely separate. So yeah, this is not expected to work, and that's what the kind of result you would see. Int fd for file descriptor, and then we will use write. I think has fd actually, because we're going to have to do the carriage turn as well. And then for good measure, we'll close it. There's no error checking or anything going on here, but if that's the correct usage of write. Write is a standard C function. Might need to include some more headers here, but first let's change open file here to instead return an integer. File descriptors are integers. We use open create. If it has to create it, then you get si read word with si write permissions. Int. Actually, don't no longer need standard IO. I do need some. So I think it's like fcntl.h and io.h. So all it does is create this file. Okay. Make sure our import library is up to date. And then try this out. Do we actually have a text file? We do. Let's delete that. We have errors. No member called right in the global namespace. Might be fcntl.h. Control F9 for compile. No member. io.h. Woohoo! All right. So let's run it. Hit the button. Oh, there's no text in the file. So it definitely opened it, or created it and opened it. The write fails. Okay, what's the file descriptor value? 4. That looks like a valid file descriptor number. The -1 would be an error. 0 is like standard inputs. 1, I think, is standard output. 2 is standard error. I don't remember what 3 or 4. Anyway, but 4 looks perfectly normal, expected. Let's see, run, step over, and the debugger should tell me what the return value of that was. Here, this way we can look at result. Okay, so we're going to step over and store the result. The result is -1, so the write failed. That should be good. What's error now? Okay. So we try the write, we step over, we look at the error now, tells us 6. Let's look at the error now to find out what 6 means. Include Windows C runtime library errno.h. Bad file number. Okay, so maybe you can't do that. So let's write to it. From the DLL. Then we look at it. Oh, DLL is able to write to it, but yep, this application is not able to write to it. So you cannot share file pointers, you cannot share file descriptors. There's also the Win32 API, create file, turns a file handle. So let's try going that approach. It returns a handle. Yeah, so let's look at create file. All right. So the desired access is generic write. So share mode. Click create always. And null. I can write to the file with write file. And then we're going to return the handle. Create file A for ANSI. Yeah, he's going to say handle H. Open file. And then we should be able to do the same. Let's try that close file close operation. Close handle. Now, I'm not actually going to write to it when I click the button from the application. It's the DLL should write to it, though. Okay. Click it again. Okay, it's recreating it every time, though. So let me close that. Delete that file. It's not there. Just run this again just to confirm. File's not there. Click the button. File's there, it says DLL, so that's good. So we know we're successfully opening the file using the handle to write to it. So let's try doing the same write operation on the handle from the application. So the DLL will write the letters DLL with a line feed, and the application will write exe with a line feed. There we go. To complete this example, rather than writing the static string exe with a line feed, let's go ahead and write the actual string that's in this edit box. There's no line feed here. If we want to add that, we could modify the string before we convert it to UTF-8. Say string uster. This might need to be Unicode string. Unicode string. And then change this. So that'll give us the line feed at the end before we convert it to UTF-8. Let's go ahead and run this again. And look at the file. So currently has DLL and exe in it. And again, now we see test. The DLL writes the string DLL when it opens the file. So we'll change this to seems to work. So that's a little bit more interesting, passing a dynamic string context rather than a static string. So we can share Windows file handles between DLLs and applications. And it should not matter which entity opened the file or which entity closes the file, and they can both write to it. Of course, if you have threads or any other concurrency, that could be an issue, but at least sharing the file handle is not a problem. To review, files opened in the DLL cannot be accessed or closed in the application, and the reverse. If the file is open in the application, it cannot be accessed or closed in the DLL. This is true for all the standard C file opening and access functions like fopen and open, and also true of any C++ methods like IOStream objects, the Microsoft MFC C file object, or the Embarcadero T file stream object. The one exception, however, is files opened using the Win32 API functions OpenFile and CreateFile are shareable between DLLs and EXEs.
Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
In this video segment, I'm going to be demonstrating how to create graphical user applications, Win32 applications, using Microsoft Visual C++, using the Visual Studio IDE, File, New Project option. Once you get to this menu, New Project dialog, you will see some subcategories under Visual C++. You'll have MFC category. You also see a Win32 category. It's kind of interesting because MFC includes Win32, but if you want to create a graphical application without using MFC, that's Microsoft Foundation classes, you can do so here. That's this Win32 project. It's actually a graphical project, does not use MFC. It's really not C++. I mean, it's a C++ file. But you could really compile this as a C module pretty easily with very few changes. However, extending it, adding more visual components can be very difficult. It's a very basic graphical application. I can go ahead and demonstrate what that looks like here. So you have a lot fewer options if you don't choose MFC. We're going to say, it's a Windows application, although we already chose that. We're not going to use Active Template Library. So you don't get a whole lot of options. It does generate a lot of code for you. And you can run this right away. So this is what it looks like if you create a brand new application in Visual Studio, Visual C++, and do not choose MFC. And like I said, it is technically C++, but this would compile as C pretty easily with very few changes. To get an idea of the amount of code that's generated here, let's go to this project directory. So about 7 kilobytes of code was created. I think there's some resources created as well. That's this RC file, so that's probably that icon. You'd also have an ICO icon file. The output files go in that debug directory you see here. If it were doing a release build, then it would go into a release directory by default. Anyway, like I said, this is not MFC, but it is kind of interesting, so I just wanted to show that to you real quick. Creating a new application, this time using MFC, we're going to choose that MFC category under the new projects, project templates, and this time we're going to choose MFC application. I'm going to put it in a different directory. And we're going to do a little stopwatch application, so I'm just going to call it a stopwatch here. Okay, so this is the first sort of busy wizard page that you have when you're creating a new project. You have a lot of options here. The default is multiple document or MDI application. This is pretty old school. The simplest is a dialogue-based application that has the fewest pre-populated controls, visual components in it. You also have fewer options as far as what you can do. A lot of these options get grayed out or disappear when you choose dialogue-based. So you have a single document, that's the SDI, all the options are available. Multiple document, that's where you kind of have a bunch of documents simultaneously open as child windows of your application. Dialogue-based is where you get a single dialogue, kind of shows in a little graphical representation up here of what a dialogue would look like. So you usually have an OK and a cancel button, maybe an apply button, but not a whole lot more. You usually don't have menus. You might have sub-dialogues that get created or child dialogues that pop up, but usually you don't have too many sub-menus or sub-forms and dialogues that appear. And then you have another option of this multiple top-level documents, which I think just opens what looks like a bunch of sort of main forms. So it gives you kind of a graphic representation of what the different options are. We're going to go with dialogue-based since that is the simplest option. And we have an option here of how to link in the MFC library. We can use that as a DLL, so that's dynamically linked. That means our application code won't actually include the library in the executable. It'll be in a separate DLL file. You will have to have that DLL file at runtime. The other option is to statically link it into your executable, and that means that your exe will be bigger, and you can't change the version of the MFC library underneath or at any time after you build it. It's permanently linked to that version of MFC. So kind of depending on whether your deployment and runtime use cases about memory requirements or disk space or maintainability, extendability, maybe you want to be able to support replacing the version of MFC later without changing the executable or rebuilding the executable, then you want to go with the default of a shared DLL. Here you have another page of options about the style of the frame, what kind of menu items you want available by default. An about box, for example, is kind of gives you the version of the application if you want that. System menu, typically that's kind of like your upper left menu where you have some options like minimize and close, etc. We'll go ahead and go with the defaults here. Now, another page of options, ActiveX controls if you want those. If you don't, you can probably save some code space by turning that off. You have some other options like Restart Manager, which can automatically do things like restore documents and such if you want that functionality. But what I don't know is how you would go back and change these things later if you change your mind. And you go, oh, well, now I do want the Restart Manager. So I'm not really sure how you would go back and re-enable that option later. So you might want to carefully choose your options when you go through this wizard the first time, hopefully get it right. Let me see. So classes that are going to be created automatically, one for the application, one for the dialogue. You want to choose your project name carefully. That way your class names are created meaningfully, and if you have to change these later, that can be kind of a hassle. So it's good to name these things correctly up front. When you click Finish, it's going to create your application. And this is the most basic form of application that I can create in Visual Studio. You do have your sort of basic form with an OK and a cancel button. You also have a palette of controls that you can easily drag into the dialog to add those visual components. There's not a whole lot of categories here. Pretty much that's it. Dialog editor. So these are all pertinent to the dialog. What you won't see here are things like a menu bar, which typically will go across the top. You'd have like file and help, etc. You won't see that as an option here. You also won't see a status bar. Typically on the bottom, you'd have a status bar, which could show multiple panels of text, usually representing the state of the program as it's running. You won't see that as an option. So you're kind of limited in the palette of what you can easily drag and drop here. Let's go ahead and run this application and see what it looks like without changing anything. Actually, let me look at the source code first. Let's go ahead and analyze how big is this thing. Just because we created a minimal application, how much code did Visual Studio, Visual C++ create for us? Okay, so about 10 kilobytes or 1,100 lines of code right off the bat. So it's like boilerplate code. We also have a resource directory. So that's where an icon and another RC file. So we've got two RC files. We've got a solution file. That's that SLN file right here. That's kind of like your workspace file. Your project file is this VCX proj file. So you're not expected to edit those by hand, although they are readable if you want to look at them. XML. Okay. Since we're going to have a stopwatch, we're going to want some kind of representation of the elapsed time. Some options we have are like an edit control. Typically that would be something where the user could edit it. You'd also probably have a label. You have a search facility here. No label. How about text? Static text. So a static text control is kind of a read-only visual text component, and does not have any kind of frame or background, similar to this to-do comment here that Microsoft put for us, so we can remove that. But let's say we want something that's maybe a little more visually appealing, so we'll go back to an edit control. I think that's a better option here. But there's no code associated with this edit box by default. So to create that, we're going to right click and say add a variable. And the main thing we're going to do here is set the name. We want to make sure we give it a good name initially. So we'll call it edit box. Now if we want to look at our code that was created, so we have stopwatch, CPP, we have a header file. It's in the dialog header file. So now we have our new edit box, and the type is cedit. So if we want to know what we can do with this edit box, the best thing to do is put your cursor on the class, the cedit, hit F1 for help. And then I'll send you to Microsoft's documentation for that class. It doesn't really have much in the way of properties. Everything is kind of a method that you call, so a function call. It has a lot of functions about controlling the limitation of the input and modifying the selection and copying and pasting and stuff like that. But if you want to manipulate the text or get the text, you really want to use these inherited functions from the cwind class. So we got set window text and get window text. So that's how we're going to actually modify the text of that edit box. Since this is a stopwatch application, we're going to want to put the elapsed time in that text. So we'll say do it in seconds, just to be simple. So we'll need to create a timer. And the way you create a timer is you go to the class view, find your dialog. Down here in the properties window, so that's this box here, you have a messages button. You click the messages, you go down to WM timer. And then if you double click or you do a drop on or whatever, a drop down, you'll have a option to add an on timer function that gets called every time the timer ticks. And it resets the timer each time. That's what this does. So we can remove the to-do comment. Now what we're going to want to do is keep track of the amount of elapsed time. We'll do this with a static variable. We could also do it with a class variable or a global, but just to keep things simple, we'll create an unsigned long here. That way when it rolls over, it just goes to 0. It doesn't go negative when the number gets too big. We don't want a signed integer here. To assign this to the edit box, I remember I mentioned that inherited setWindow method, setWindow text, excuse me. And then you're going to pass it a C string. That's the Microsoft MFC string class. So we need to construct a C string first. So that's the name of our string, our C string instance. And when you instantiate them, you just create an instance. You don't have to call new and use a pointer. You just instantiate it directly. And then to assign the current count value, there's a printf style format method. And then you have to pass it a format string. We're going to say it's unsigned long. Now, this is multi-byte, wide byte, so we have to do that to get our multi-byte string constant. And then we're going to pass the count value. And then after we set the text, we can go ahead and increment the count. Now, by default, this timer is actually not going to be enabled. So when we run this program, it's not actually going to set any text in here. We could do this, say, on one of these event startups, like on init dialog. The function that we want to call, let's say, is called setTimer. This is a standard MFC application method. And it has a few parameters. Let me see here. I think the first one is the ID of the timer. Next one is the amount of milliseconds till the timer fires. And then you can pass it a function to execute, a pointer to a function to execute. We're just going to use null because we're doing it based on this this timer handler that's built into the MFC handling. So we don't need to actually pass a function parameter here. We're going to build and run. Oh, look, okay, so our counter started at 0, it's incrementing and setting the value, and that would go all the way to the limits of an unsigned long, which is 4 billion something, and then it would roll over to 0. So you could use a bigger integer if you wanted, or do something else if you really cared about that issue. Now, OK and cancel don't really matter what we click there, so maybe we want to go back to our resource view. We want to look at our dialog again, so we find it here. Double click. And delete this button. We want to just change, well, cancel's fine, but maybe we just want to change that to close, or maybe we don't even want that button because there's no effect. Yeah, we didn't need those buttons. But let's say we do want a button. Just go ahead and demonstrate how that works. So let's say we want to start with the timer not running. So we will need a button to start the timer and maybe another one to stop it. Or maybe just a checkbox. You could have a checkbox. Let's do that. Let's use a checkbox. Oh, I want to associate a variable with it so I can check it. So just dropping that control into your dialog does not create a variable that you can programmatically access this checkbox. So we'll call it timer enabled checkbox. So the timer is always running, but we don't want this code in the onTimer handler to do anything if that checkbox is disabled. So the way you check it, so we had that, let's go ahead and look again at our header file so we can see what the type is. It's a C button again, so if you want to look at C button, see what you have available, F1, Again, it's a bunch of methods that you can call. The one we're interested in is called getState. Here it is. And it returns a bitmap. So we have different bits set, and we have these constants we can use to check them. So it doesn't just return one state parameter. It kind of returns like an array of booleans in the form of bits. Kind of very low level method of checking multiple state values. We want to call that method timer enabled checkbox.getState, and we're going to compare the return value and see if it has that checked flag. And really we want to see if it's not set, then we just want to do an early return here. Or another way to do it would be see if it is set, then do all this code here. You always want to reset the timer though. So let's try that. So it's not putting any text into this edit box because our checkbox is not checked. Now we're going to check it. The counter starts running, and when we uncheck it, the counter stops incrementing. So that the timer is still running. It's just not executing this little block of code here that we have with this if statement. So again, we now know how to start the timer. We could also just start the timer and then kill the timer. There's a function equivalent to this called kill timer. So here's cwhen set timer. The counterpart is kill timer. Let's go back to our dialog. Let's go ahead and add a button to kill the timer. So I don't like these names, so I want to change this over here. The caption, we'll call it stop. And then check caption enabled. These are a little bit better names. And then, so when you double click, it creates an event. We want to call kill timer. I think you have to pass the ID. Yeah. So it's enabled, it's counting, but we also have another way to stop it, and that just calls that kill timer. So now the timer's not firing, and it doesn't matter the status of this checkbox. So this maybe not be a good maybe this isn't a good application design, having two different ways to stop the timer, but I'm just kind of demonstrating the different ways to control that timer. And so you probably want a counterpart, which would be like a start stopwatch. So drag another button over here. Start. And we'll move this set timer. So this is where this timer started. We're going to move that to the on click for the start button. It's not just the text. I don't like the names of these buttons. So we get these macros that get created for the button name. So this is the start button. And this is the stop button. Okay, so because I didn't name it nicely to begin with, we've got some kind of cryptic names here that don't automatically get updated. So we really want this to be this is the start button and the stop button. So you can see it's pretty important to name your components meaningfully the first time before you start creating events. So on button clicked start button. Object is the end of the name. And then we have these two events that are not going to be automatically updated in our header file, so we have kind of manually rename all these things. And our checkbox isn't like a kind of an event there for our checkbox. We don't really need that. I think that was accidentally added when I double click something. So Luckily, these are the same signature. Whew. So that's kind of a pain. So the functions are actually named right. Well, you can look at it either way. The content was wrong, was backwards. So enabled, and we're started. You click stop, it stops. Start again, it restarts. Very simple stopwatch. We have an edit box, a check box, and 2 buttons. There's your very simple MFC application created with Visual C++. Now that we have our application complete to this point, let's double check how much code we have generated. We're going to use the word count program. That's this WC utility, common Unix utility, all the source code CPP into H files. So we know we started with about 1,100 lines. I think it was 1,150, and now we're at about 1,245. So about 100 lines were added to the code. I didn't type 100 lines. I maybe typed 2 or 3 lines. So that's how much code was auto-generated by the IDE. And then, like I said, maybe a couple lines that I typed. So it gives you an idea how much total code and how much of that is boilerplate, which is, 90+% of it.